everybody. People coming into the chat here. What's up, Jason?
Hello, hello. Jason, I haven't heard from you in a while.
Right. All right. I'm rolling. I think everybody else is.
I am rolling as well. Yes.
I think we're good here. Just checking
Test
all the
1 2 1 2.
feeds. Let's see what we got here.
Testing.
I think we are good. Going to post to my Facebook. You know, so my one friend that cares about motion graphics on my Facebook page can see it. And there we go. Cool. Looks like we are rolling.
Ready?
All right. Cool. All right. Here we go. Where's my notes?
You want to do a
There
sync
they go.
clap at all?
Oh, yeah. We need a sync clap. Here we go. 1, 2, 3.
Perfect.
All right. Cool. All right. Here we go. What's up and welcome to another Mograph Mocast. I'm Dave.
And I'm Matt. Joining us today is our good friend, Mr. Jules Urbach.
Great to see you guys. Always a pleasure. Always a pleasure. You're looking. Look at this. I love this.
Love
by the
it.
way.
Love it. Love it.
And Mograph
Great.
is a supplement to
I
our
wear
site.
it out all the time.
And Mograph is a supplement to our site, mograph.com, which is a motion graphics tutorial site with tutorials, plugins, podcasts, and other Mograph stuff. And on the show, we talk about everything ranging from motion graphics to Cinema 4D, After Effects, plugins, render engines, doing business, doing taxes, being a contractor, or working for the man. You can email us info@mograph.com. Let us know what you think about the show. Questions, comments, concerns, queries, grievances, artist suggestions, show topic ideas. We're on Facebook, Twitter, all the things. Mostly you'll see us posting on YouTube and mograph.com. Email us. Let us know if you have any topics for the show about the world of motion graphics. It could be something technical, artistic, doesn't matter what it is. Just hit us up, and we will attempt to answer those questions for you.
Yes.
And we have a lot to talk about today. We're not going to do anything except just get right into it because if you've listened to one of these shows before, there's a lot. There's a lot to take.
A lot
in.
of meat. A lot of good
Yes.
meat.
So it's going to be fun. So I don't really know where we want to start off today. I went through the entire talk, your previous talk yesterday, and I took like pages of notes. I'm pretty sure that you're well aware of everything that's in the next version of Octane, but I've got it laid out here just in case we've missed anything. I guess we could really start probably with some of the real-time stuff that's going on. The world of real-time is here. You've got Unreal, you've got things like Brigade coming out, and virtual production, of course. One of the things that kind of interests me is, you've got like this mix between rasterization and Octane that you were showing off. I think with like the Enterprise Bridge, interested in that. What's going on in the world of real time with Octane?
Yeah, real time. It's a great place to start because I think real time is now. It's a tool that's useful for artists, even above and beyond sort of the things we're doing with Brigade. Now, I should start by saying, giving an update on Brigade because that's coming in Octane 2022.1 RC1. Now we're that's a few releases out, but we've been putting the pieces for that in there. So you have a little real-time button that speeds up the viewport significantly. There's no film buffer on the CPU anymore. That is in preparation for Brigade kernel. But everything that Brigade will do, and the way that we decided to ship this was that nothing changes. It's all Octane, and there's different layers. So if you want to have the full filtering, which does all the temporal, filtering everything, that's the last piece, and that's going to be very useful to get, basically zero noise while you're running in real time. That's what the Brigade benchmark is doing. But then you'll have sliders that add a little more noise that give you still something close to that. And I think that when you're looking at getting something that's pretty close to final render or exactly the same quality at the very end, that's the first sort of target that we have for Brigade. There is a layer underneath that we're using heavily, which is like, well, if you have a rasterizer and you want to mix that with Octane or Brigade, and that's Unreal, for example, and Unreal's huge for us, huge because of virtual production. That's a market that is exploding. I mean, every TV show now that's interesting, you know, but not just The Mandalorian, you know, the Star Trek shows. We used it for the Gene Roddenberry archive project, where we loaded up, you know, these beautiful Octane rendered scenes, and while we're moving the camera around, it would pull that in, and we would switch to Unreal. Real-time would set it up, and then we'd print it on render. Right, we'd do the final frames there, so we'd have that as additional data. So virtual production is where a lot of that rubber meets the road for a lot of work that artists are going to be doing. Then you have the ability, I think, if you're doing stuff that is somewhat interactive, and there's a lot of great work that Epic has done with blueprints, and that's sort of like a Mograph for interactivity that's pretty easy to use. We have a lot of artists on staff at Otoy working on Roddenberry, working on the Alex Ross, Marvel, and other stuff projects that are using blueprints to set up very simple triggers to make the world, the art that they're doing, come alive. And we can store that in an OrbX file because Epic has thankfully open sourced all of Unreal, created a very permissive license, which effectively makes blueprints like USD or EXR. It's just a format that we can incorporate. And there is a lot of interest within, you know, we're part of the Cronus working group for GLTF. We're involved in many other things. It's going to be something that's pretty important, I think, for the metaverse. It's not going to be everything, but I think there's such a great amount of understanding in Unreal how to do interactive pieces that I feel that's a great place for us to add things like Brigade and a lot of our, you know, AR and VR stuff as well. And I feel like that's the state of real time these days. There's a lot. The Brigade, though, for sure, is going to have the ability for people to just do, and it's scene dependent, right? Because there can be scenes where you're still sort of outside of the Brigade real time, you know, filtering piece. Where there's some noise, but for a lot of other things like that, Japanese garden's a perfect example where you can just go right to from real time into final render, really. And as we sort of keep going, I mean, I think this first release of Brigade is coming out in you know, this summer. There's going to be more versions, there's more work, there's more hardware coming, right, that can improve how that works. So if we didn't have hardware ray tracing, which was introduced back in 2018, having Brigade functionally work wouldn't be great. You know, it would just be a third the speed, right? Which is not what you want for something real time. We are going to be having Brigade on the Octane X app, you know, and then Octane X on the Mac. It just won't have hardware ray tracing, so you'll feel that probably lack of speed. I think at some point that might change. You know, everyone's trying to add hardware ray tracing. I think Intel and AMD have already announced that they're doing that. But yeah, I think that real time for sure is getting to the point where it's a really significant part of the workflow, and hopefully what happens is that you're not as stuck in, you know, OpenGL preview mode or, you know, rasterized mode where it's all, you know, where it's not final quality. So I think that's where a lot of the real time work that we're doing, you know, tries to fit in, so that you just have something that's much more instantaneous, you know, while you're working and creating things. And Octane's are really very close to that, very close. And things like caustics are now basically almost, you know, instantaneous in the viewport as well with the new kernels. So there's and a lot of the little funny tricks and pieces we added in the Brigade demos, those are now in, they might even be in the next XB2 release, you know, the very fast fog and the God rays, not even the fast ones that we added with Spectron Vectron back in 2018, but the newer stuff where you want to have just instantaneous height fog done, you know, mist pass in there, instantaneous slide shafts in there. So it's actually in the post-processing pipeline. It does a ray tracing pass that was from the Brigade demos we did before. It's now going into Octane. You can use it, by the way, with any of the kernels, not just the Brigade one. So that's pretty cool.
What was the... I don't use PCM that often. What was the deal with, you know, so for Photon Tracing, you said it retains full IPR interactivity. Was there something before that was kind of stopping that from happening? I wasn't aware of that because I didn't really use it that often.
Yeah, well, so the Photon Tracing kernel is a brand new kernel. Like, we just wrote it from scratch. I mean, obviously it's using a lot of code from other kernels, but it was designed to initially fulfill the features that were in a paper called progressive photon mapping, where you kind of have almost, it's like a biased approach, right? You render the caustics from one camera and the other camera is there, you know, capturing that. And the problem with that approach is that while you're doing this rendering, you're doing that. If you move the camera, everything sort of goes to heck, you know? And so the improvements that we made as we're doing it is, you know, and people were calling us out, like, well, when you do this, like, it's not going to work great because it's not going to be fast. There's like 5 other techniques that are related to caustics and photon tracing and path guiding. We applied all of those in there, and we ended up with a kernel that not only did what that paper does in real time with no loss of interactivity, but even does volumetric caustics now, which is a big win. So it's great. I mean, I think it's state of the art. And again, like with other pieces of the tech, we're going to keep working on that. But that gives you it just makes caustics either, depending on how you set up the scene. It can be real time if they're sharp caustics, but even if it's like a 30-second render, you're competing with something that would be 1,000 times slower in path tracing, or and PMC in some respects I don't think is that necessary anymore. I mean, it's there, we're keeping it, we're maintaining it, but you may not need it really with the photon tracing kernel. So that was the idea, is that, and ultimately your caustics are now really, really, really cheap, and they look really good.
And so as far as Brigade goes, like for me, I'm excited about it because it's like, I'm a Cinema 4D person, obviously, but like I'm dabbling in Unreal. I don't know if I'll ever be like a full Unreal person, right? So I'm going to stay in Cinema, and so that's why I like Brigade for that real-time stuff. I could just get out quick passes and stuff like that. But what I originally was imagining in my head, and I might have been the original plan for y'all, was that Brigade would be a kernel drop-down, and I think you mentioned something about every individual kernel will have some sort of option to run faster in a Brigade-like way. Is that correct, or am I completely off on that?
Yeah, no, you're actually correct in all those respects, because what we're doing in the end is having, there is a Brigade kernel, and it's a whole different thing. It renders differently than all the other ones, and that's the closest we can get to something. I mean, if you played with something like Omniverse, for example, their approach is not too dissimilar to what we're doing with Brigade. I mean, obviously, it's we've been working on this for a while, and I think what we have is really good, and it's meant to be used inside of C4D or Blender or things like that, where that can work. Like Blender, of course, has Eevee, and Maxon has Redshift RT. I mean, I don't think Brigade is any of those things, to be honest. It's much closer to just fast Octane with temporal denoising and filtering, and a lot of extra bells and whistles. So when you go into that mode, there, the filtering itself, it's like the denoiser. You'll have some changes that come from that. If you turn all that off and you still want to have all the speed improvements we made for that Brigade kernel, but just use direct lighting or path tracing or photon tracing, you'll have that. And in fact, we've even thought of having like a slider where you can kind of mix those together. But the Brigade kernel itself is initially going to be some superset of direct lighting, and we're just like, in the end, no, you can kind of like it's going to be an actual add-on where turning on real time and turning on Brigade kernel are global flags. So if you're in direct lighting or photon tracing, Brigade kernel will just basically absorb those parameters and give you back a filtered result, basically. So that's how it's going to ship. And I think that after testing it myself, that makes the most sense. I mean, effectively, if you had a Brigade kernel, what if you wanted to have that sort of gradient between direct lighting or path tracing or photon tracing? Ultimately, just having that set up normally, and then having the Brigade kernel itself be almost like a separate grouping or separate info box where you can turn it on, you can turn that kernel mode on, and any setting you have in the other kernels normally get absorbed, and then the extra ones are shown in there. That's, I think, how it's going to work best. And we'll see. I mean, between RC1 and GM and which is Goldmaster, we'll see how user feedback sort of progresses. But one thing I will say that we've run into, which is something that it's going to be almost like a DCC per DCC issue, is if we don't pop up our own IPR and we're going through the system that goes through the viewport and it's through the CPU, you're going to lose a lot of that speed. So, for example, even Brigade inside of Unreal, the first thing we realized is we've done all the speed ups, but Unreal normally, ingests the viewport from a third-party render. We're one of the few through the CPU. So thankfully, they've added this thing that does shared hardware, GPU surfaces. We're going to use that. It'll be full speed, and we need to do the same thing inside of C4D. And notwithstanding that, you'll have that in our IPR, pop-up IPR, which we're also building. And Ahmed, our C4D developer, has been building an entire interface separate from C4D that can be inside the IPR, that has the node graph, that can work in a standalone app. It doesn't have to be the existing Octane standalone. It'll be sort of a version above that. Thanks to our license from Maxon, we'll be able to load Octane for C4D files into this app and do edits, send it to the render network. Also, it'll be able to load other renderers as well, including Arnold and Redshift and Cycles. And if we do our job right, we might even be able to get Unreal in there. And I think the Unreal stuff is there's the renderer in Unreal, and then there's the whole app itself, and then there's even the interactive pieces in the node graph. I consider those three separate things. So there's a world where you could probably, if you wanted to have any arbitrary renderer running inside of Octane, we can do that. We've shown this with Arnold before. That's because we can load in a Hydra render delegate, or we can just load in a whole separate app that's hooked into the system, like we're doing that with Embergen. Embergen's own renderer now runs inside of Octane as an AOV. It can be composited. You don't actually need to have it pass through Octane or Brigade. And so that's a very powerful system. We're most likely going to get that working first with Unreal, where you could just use the Unreal Render as the AOV pass along with all the other passes. There's multiple render pieces is very powerful. And to that end, one of the things that we just shipped, GPU Compositor. So the Compositor nodes in Octane were like, we put that in there at the last minute, I think in 2021, and it was CPU bound. This, to get ready for Brigade, to get ready for all this crazy stuff, we moved it to the GPU, and now we're going to have OSL shaders, anything you want. It'll almost be like a texture, in and of itself for each of these AOVs. And the compositing can then take things from other renderers, from Brigade, from, you can even run Octane in a whole separate process that's not just headless, but actually is running, a render target or a camera on a whole other machine to bring those in. So those are all the things that I'm showing in the talk. There's a lot there, but that system, I think that sort of ability to sort of branch out from the core renderer into other renders, into other, almost clones of your Octane instance running in a separate process. That was always our plan for out of process rendering and headless rendering. That I think is really close to shipping because we have it running internally, and it's working great, and it's going to be applied to Blender as well. So Blender, we had a separate Octane server. You can now just boot up any instance of Octane, and Blender can send its data to it and get information back. And you can start to see how this becomes a hub where you can run Unreal and Blender and C4D and have the geometry of the rendering be switched between all of them or connected. Omniverse is trying to do that too. But I mean, I think that, from the perspective of artists using our tools, it'll hopefully all just work and interoperate in this way. And in certain cases, like with Embergen and LiquidGen, which they're doing some even other things with terrains and things like that. We want to allow you to use everything, and they have a very nice real time render, which we have the source code to for volumetrics. It's not as accurate as what we could do even in Brigade or in Octane, but maybe that's not the point. And so already people use Embergen for plates and for compositing, and so this will be like in the core essentially once we hook these pieces up, and then you'll also have Brigade as well. So I think that this is a workflow for the future that again also speaks to the ability to sort of mix real time with offline, but also the idea is that we just get Octane quality as it is, to be as close to real time as noise free as possible. And that was the first sort of goal that I had with Brigade. And I think beyond that, we have more things from the Brigade sandbox, which gets rid of spectral rendering, can make it even faster, cleaner, and things like that. So we'll be adding those pieces probably after to just give it even more options. But I think that what we're starting with out of the gate is pretty good.
And is that considered MultiStream? Is that what that is? Is that what it's titled? MultiStream, multi-engine?
Yeah. So there are three multis. There's multi-render, which is you can. This is where you can drop in Arnold or Octane. It's just a different render. You have both. That also allows us to load in any Hydra render delegate. So that could be. It couldn't. It would be RenderMan. We've tested it with Cycles and even Pixar Storm, which is a real-time OpenGL renderer. So that's multi-render. Multi-engine is a bit different. We have basically 3 DCCs that we want to essentially turn into something like in the core of Octane, you load a USD file or a Limbic file in an Orbex. It just works. It's a proxy. What we want to do is do the same thing so that you can take a C4D asset or an Unreal project or a Blender project without saving as an Orbex, but load them in an Orbex or have those things operate as a full stack within your session, and expose as much of those pieces to authoring in the parent app as possible. That is multi-engine, and that is something that, for example, allows us to take a C4D file and run it on the render network, or run it in Octane standalone, or run it in another DCC with literally the full Maxon app. I mean, that's a bespoke license where we can run plugins, we can run X particles, we can run anything we want, including Octane. That was the point, and that is something that we worked for a long time with Dave. CEO of Maxon has been great. I mean, that's a license that changes the entire ecosystem for us, and I think that shows also, I think, where Maxon's thinking too, that they're an ecosystem player, and I love that. So that's where multi-engine came from. Unreal, same thing. You want to do interactive content in blueprints in Unreal. You want to mix that with your C4D scene without changing it and mixing these together. There's going to be a way to do that, probably from within each of those 3 DCC tools, or at least to load in those features or scenes. And that's where multi-engine sort of fits in. Where MultiStream fits in, that's much more like network rendering, but with a lot more interesting features. So that allows you to have essentially 2 instances of Octane that can essentially send data back and forth a little bit like what's been going on with Blender from the very beginning. Because Blender is GPL, we could never ship Octane, we could never directly link it into Blender. We had to have an Octane server that would be a special, pop-up, and then you would connect to it and you'd be able to use Blender as if Octane were integrated. What we've done is we've generalized that, and we're solving all these things that have been on the roadmap for years. Headless rendering will work with this. So in other words, if you wanted to just send all of the data to, and you don't necessarily need a network render node, it'll be like just some version of Octane standalone that boots up as a render node, and that can basically operate as headless rendering. It can also operate on the same machine as an out-of-process rendering system where no rendering is done within the DCC. It's all sent over the wire to this other process, and that's pretty cool. But that same system means that you can then interlink live potentially different DCCs on the same machine across different machines, collaborate, because essentially anything can host a scene node or geometry that can be fed into the other DCC. Now, how those things are edited or exposed, I mean, like right now, we need to do more work allowing you to edit an Orbex file, but that's something that we're going to be sort of layering on top of that in tandem. And what's interesting as well is that with the render network, right, we send, essentially a atomized version of the scene to be rendered on the cloud, rendered on the blockchain and these decentralized nodes. What we can do is we can turn on that very same system to basically be ready for real time, right? Ready to basically ingest data and render it back to you. So in other words, having your GPUs exposed live through the render network is viable with that system. Latency aside, it's still pretty useful. And I think that also will allow us to just allow nodes to do real time that is not necessarily driven by a DCC on the artist side, but just, play in this world. Here are the blueprints. Here's how this works. Use Octane, Brigade, and Unreal together. Save what you're doing and render it out as a final render. Those are the kinds of things that all these pieces together, make happen.
And I love like the fact that there's, you can have a node that's Cinema 4D, a node that's Unreal, but I think you even mentioned that you could even have the whole editor interface of Unreal in that node, which is incredible. And
it is incredible. So Epic has made that easy for us because they basically given a license not just to Unreal Engine and Unreal Renderer and blueprints, but also to the actual UI for the editor as well. And we're thinking about this also. We did this with Sculptron. So Sculptron was our first internal test where it's a separate app, but it also now works as a multi-engine node. All the sculpting things you're doing in that app can actually pop up as a window in Octane standalone or in the DCC plugins. That same interface will allow you to pop up a Blender window or an Unreal window and edit that node, so that even if we don't expose everything within the host application can still create a panel where you can have all those features there. Yeah, super powerful. It's like that's how multiple applications might work if they could really interoperate nicely, or iframes in a web page. That kind of concept is where we're going with these things. And in the case of Cinema 4D, we're not going to necessarily pop up the full interface. We don't have a license to the C4D UI in other apps, but we do have the ability, for example, for Ahmed's node graph and all the things that he's done to be layered on top of that. And honestly, if you're creating in C4D, you should probably be in C4D. Yes. But the arrangement with Vaxxon is that if you want to take data out of that and do other things with it, we have all the C4D. We've got the basic interfaces that most artists are used to. We've got all the plugins that could work. You'll need licenses for those. But along with the renderers like Arnold and Redshift, which we worked out for the render network, the Maxon Cinema 4D hub is such an important part of that, because everything you do in those tools then becomes modular and can be brought into other things. You could, for example, use that within Unreal to just take your C4D files as they're all prepped, including Octane Scatter, and that would work inside of an Unreal Engine session. And vice versa.
So this is bringing up an interesting point. So does that mean, like, for example, right now when someone's working in Houdini, they could build out something in Cinema 4D, then have to go through the process of exporting it to Houdini and then manipulating it from there. Are you saying that with these individual nodes, we could work solely in Octane standalone, start building stuff in a C4D node, then bring that over to a Houdini node, just like easily?
So what will happen is if you export to Houdini, or you export, let's say, to Orbex and bring it somewhere else, imagine not having to export to Orbex and just taking your C4D file and loading that in Houdini directly with Octane. Because Octane will have, they'll have the Cinema 4D engine. I mean,
now you're talking my language.
With about the same level of, and having the ability to, the license for Maxon also allows us to do live linking as well, but the portability of the data in its native format untouched is very important. And we're not going to do that with every DCC, but we are doing it with, we already have USD, which is already a pretty broad thing inside of Orbex. You could, in theory, then to put a C40 file, so maybe there's more things than just a C40 file you want to transfer it over. You could put that in Orbex, but it'll just be like a wrapper or not. But either way, C40 becomes a native file format of the whole ecosystem. And we're going to do that with Blender as well. I mean, it's obviously open source. It's a little trickier to the GPL, but it's certainly doable. And then Unreal is sort of that third one where it's like, yeah, there's so much in this. I think Epic is poised to have a lot of the stuff in there become part of open standards. Like we're helping with that. We have ITMF, which is based on Orbex. So you can sort of imagine, Orbex or ITMF, which is the open source version of that, being a superset of everything we've already done, and USD and all these other things, and also Unreal, Blender, and C4D. Like, why not, right? And Houdini, there is Houdini Engine. We're thinking about that. I mean, we just have so much bandwidth to do these things. But yeah, there have been efforts to bring Houdini Engine, for example, into other apps. But I think that some of those things are missing the completeness of having a full-on render and everything that you're doing in one being brought to another. And honestly, I think that's the magic of what we're going to be able to do with the C4D Maxon license. I mean, it's pretty great. And I was thrilled that they're thinking that way. I mean, they've done stuff with Cineware before, but this is a whole other level.
Right.
Sure, we're not going to be the only ones doing this, but I'm pretty sure that we're the first. So for that, I'm excited to get all this tech out there.
And I don't know if it's Dino or Dino. I apologize, but I was going to say the same exact thing there in the chat. Ahmet he's gonna have to clone himself, and I was thinking about that. I was like, how is he going to get all this LiquidGen, EmberGen stuff integrated into Cinema? Because I want to use it in Cinema, and now you would just essentially use a node that would be EmberGen or something, right? And just use it that way.
So we have to also think about this is not just what Otoy can do, but I mean the whole benefit of having partners that we started bringing in a couple of years ago, starting I think with Jenga, and we have Architron, which is this which is basically a Lightwave Cat. Lightwave's a dead app, unfortunately, but that code is going to be turned into architectural plugins and modules for all the DCC tools. We are working with the Jenga effects guys, and we have a deep relationship, source code transfers, and all that stuff, so that their stuff can go right into C4D. And they're also, I mean, they've been pushing the envelope. So it's like, when does this make the most sense to do the integration? Because Ahmed's waiting also to do the UX for that and all these things within each of the DCCs, for his DCC and possibly others that might use some of his work. But one thing that I've been waiting on for EmberGen is sparse volumes, right? Because if you are always in a box, that's beautiful and it works great. But if you're rendering things in massive scene, you need to be able to have almost infinite, infinite sparse volume. They just got that working. That is huge.
That's amazing.
That is amazing, right? So I think with that, then I'm like, okay, now you can start to do production scenes with this. And we're still early days. Same thing with LiquidGen. There's also, I mean, there's some great stuff, frankly, in R26 with cloth, deformations. Those can now be brought into potentially other things. Like if you want to simulate things using anything in Cinema, could run in Blender, could run in Unreal. I mean, it's weird, but that's just how it works. We aren't going to be popping up Maxon's interface, but if you set those things up in C4D, those things would then operate in there, and we'd have our own, interface into those that would be built by Ahmed, and that's going to be pretty sweet.
Would it be similar to the way that Houdini's engine works, where it's like you can kind of create your own plugin and then bring that into C4D and still have those options to mess with, versus the entire software?
Yeah. Well, I think in this case, we do have the entire software. I think my guess would be that if you have a Maxon One account, we'll probably be able to pop up the interface at some point.
Cool.
Because it's everything. It's just, we just don't turn that on because our arrangement is not to do that unless you are a Maxon One user, and that's still probably further out. But that's the intent. I mean, I don't think that there's any reason for Cinema 4D not to run if you have an account that operates it. That's one of the kind of things that's simplified with them going to subscription as well. But even if you don't have a Maxon One sub, all of C4D will work without the Maxon interface, but with ours for those purposes. And I think that's very fair. I want Maxon to succeed, and I want Maxon One users to be able to leverage everything. And I think Maxon does as well, even within our tools, if you have that account. So I think that's where it's heading. The Houdini Engine, has been integrated in a bunch of places. There's wrappers for Unity and Unreal and C4D. And we will probably take a look at that. And I think that that's something that we'll be investigating. But I think the things that we're doing, I mean, I've never quite seen a full application with everything, not just a library version of it, but just everything in there as an option to start with. And we have that with Unreal, and we have that integrated with the Maxon integration as well. So, it's the ability, for example, of C4D2 pop-up interface. If we ever, do decide that that's something that we can work out with Maxon, interesting. And I also feel like with Houdini, once we have more developers on these pieces, I'll have them look at Houdini Engine as well. But we're just focused on these three, and that's a lot of work. And C4D is probably one of the largest and most important pieces. That also unlocks being able to send C4D files to the render network fully. I mean, you're not going to have to worry about that because you'll still test an Octane standalone or some version of that, but it'll load your C4D Octane file with plugins, so you'll know, how it runs. I mean, that's still a worthwhile test to have, but I mean, that's how we've always intended to bring C4D and other formats to render. When we look at the at the sizes of the data files sent over, Unreal projects are just crazy enormous when they're exported to Orbex. C4D there are issues, right? I mean, it's not a perfect export process. It can be done, but it's like simplifying that is better, right? And that's why we spent the money to get this license and get it in there and put a whole team on it. So,
and there's so many questions. I know people are asking about tokens and things. We'll get to that stuff later. We're talking about Octane right now. And I noticed that Omega Fox actually said, "I'm worried for my VRAM and GPU headroom." Well, good news. Let's skip ahead and talk about Meshlitz for a second. Because
yes.
I think I'm really excited about that.
Mm-hmm.
So I have to give credit where credit is due. I mean, really, the first tool that supported something like this was Unreal Engine 5 with Nanite. And the thing with Nanite is the way that it works. For those who aren't familiar, you don't store the geometry necessarily in memory or even in CPU memory, right? It's on your SSD. It's on disk. So if you have a 2 terabyte SSD, 8 terabyte SSD. Your geometry in this viewport could be 8 terabytes in theory, and it works especially well when you've got massive landscapes. I mean, I remember seeing the thing that made me convinced to do the Meshlitz as soon as possible is there's an Octane user building the Death Star, which I love. I think that's amazing in Octane. And he's like, I can't load enough geometry for the Death Star, even with instance saying I'm going to do it in Unreal with Nanite. And I'm like, that guy needs to come back to our ecosystem. And so the idea of Meshlitz is basically so Meshlitz basically give you all of that, all the same functionality, stream geometry, stream textures from your SSD into the rendering, into the GPU. I mean, of course, you need some memory. There's a buffer. There's a buffer, just like there would be for reading from disks of 500 megabytes, nothing crazy. And everything that we're showing, I mean, you're loading 40 gigabyte scenes. It could be much larger. It's really it's a streaming system. And if we didn't have SSDs and we didn't have GPU manufacturers, which don't just aren't limited to just NVIDIA. It's like AMD does it. Apple just announced it, right? For their, in Metal, you have fast load. All those things allow Meshlitz to happen. And the way that it'll work is you will have to prepare the geometry, but we'll make it kind of straightforward. I mean, it's like turning a mesh to volume kind of thing. I mean, we'll sort of pack it in for you in a cache file that will then be able to load in through streaming without having to be stored in memory. And that's a one-off process. Now, you can then take those cache things and you can just move them around and do things, compose them. But it's essentially like, an OBJ file going into, into Meshlitz probably wouldn't work. You want to sort of change the way it's stored on disk so that it can go right into the GPU from a stream. But that's a one-time process, and we're going to make it kind of built in and fast. So my expectations with Meshlitz, you'll be able to take this geometry node or stack and essentially, cache that as a meshlet. And then from that point onwards, your VRAM is freed other than that, that streaming buffer, and it can be used for other things. So that's where, the magic happens. The difference between Nanite and Meshlitz is that Unreal, first of all, it doesn't actually, Nanite's still for rasterization. And you can't really do path tracing or ray tracing at the complexity that we're doing with Octane or Brigade, but with Meshlitz, nothing changes. It'll be absolutely same exact rendering pipeline, just with infinite geometry and textures as well. So, there are people that have been looking at, I want to have mapping and other things. The idea with Meshlit textures is that those things can also just be infinitely large. So if you want to take the entire database from Google Earth, which is like, exabytes or that data, and that were on an SSD or multiple SSD, sure, that could stream in as well. And that's the starting point for where Meshlets begin and end. And that means that, you don't need to worry about out of core, because out of core isn't an issue because it's not even in memory. It's on disk. and super powerful
Will
stuff.
you need a super fast like SSD or M2? Like I don't think you can
It's
run
fast
this off
enough,
of a
right?
52 RPM, 5200
Right.
RPM like hard drive, could you?
It definitely needs an SSD. As far as the speed goes, I think that depends on how much that your stream you're pulling out. But everything
Yeah.
that we've tested, and they're not high-end SSDs. Those videos that we put in GTC, those are the real deal. That's it working, and it was. I mean, I think it was a low-end SSD. It wasn't anything crazy. It was a dev machine, so it's nothing. It's nothing crazy, right? I mean, you know, ultimately, if you have even an iPad, right, or a PlayStation, those SSD, those storage things, or you know, a MacBook Pro. I mean, all those things will be fine, and I think that you don't need anything special or crazy to be able to run this. You know, I will probably have actual numbers once we get closer to shipping this thing. You know, it's definitely not a in the next release. I mean, we're targeting at first. We're hoping to get a first build in some test format this year. So it's because it is far enough along where we know it works, and we just need integrated Octane. We need to do that work along with all the other things. But it's a major feature because, to be honest, even for us to have parity, which is important. Anything you can do in Unreal, you need to be able to path trace in Octane, and with no limits, right? No, it still needs to be for production rendering. And the nanite stuff was something that I really felt was critical and important. Lumen, I think in some respects is we don't need that because we have Brigade and we have full path tracing with the temporal filtering that Brigade has. But there's also nothing that's going to stop you from switching to Unreal with Unreal Multi-Engine, or if you're in Unreal doing virtual production, the way we did it for the Roddenberry project, which we just did a whole, we did shorts, we did filming, we did everything. A lot of it was done in front of an LED volume. Final renders were generated by Octane from Unreal, sent to the render network to do, to print out. We had all the camera data there as well. And that combination is what I think virtual production demands. And that's a huge world for us going forward. And even meshless streaming, and a virtual production stream, you have 8 terabytes of storage you want to load in or move around in. I mean, these things all fit together pretty nicely.
Yeah, I saw the video. In the video, you were showing off like a 22K file or something, and just with displacement and just zooming in and zooming
128K by 128K at 60 frames a second streaming in.
128K.
I don't know. 128K, yeah, because
Wow.
64K is easy. Yeah, 128K. And I think the data set from the image is public. It's like one of those like crazy paintings in museums scanned in, like millimeter by millimeter at one, like 1K per, so something like that. And so that worked.
How will that work within the different DCCs or inside? Do you just import it? Like, how exactly what would be the workflow for that?
So I think when you import a texture that large, you'll have the option of importing it as a Meshlit capable stream. And when on import, it will probably create the cache for you, especially if it's a texture that is originally stored on disk or referenced on disk. And that applies also to, I'll give you an example. Like if you want to load in the data set for the moon, and I was looking at the NASA data sets, right? It's like that painting. You have displacements, you have everything down to like each crater. It's crazy. And I want to have like a solar system data set. We built it for this Roddenberry project. I want that to be in like RenderDB, LiveDB, so people can start using that. We have the planetary node environment thing. Like, let's extend that with everything that could be rendered cosmically, or the stellar environment. And so we're thinking about these things, and I want to have this work with Meshlitz streaming. So having massive data sets of textures on disk with displacements, all of that, it'll be automatic. But we are talking about 120K or larger, or terapixels of data. It's stuff like that. Also, if you're fading a light field out and it's that kind of data and you want to pull it into the light field display, with what we're doing with Light Field Labs, this kind of stuff might be relevant as well. So I think that the way it'll work is on import. If you're generating all this stuff procedurally, then there may be a caching system or function. So it works very well when the data set is a mesh basically, or a texture. For things beyond that, for volume, by the way, I think that our goal is to just work with the Django team so that volumes are just generated live, and you don't need anything else, because then you don't need a VDB, you don't need to store that, and you don't even need to necessarily store the memory for it. You're just rendering it as it's as it's being simulated. Same thing with Vectron, right? I mean, that's why we're trying to build more and more tools to make those procedural things happen, because there's no data storage or memory needed for Vectron to run, for example.
Omega Fox, he's like, can you even open a texture that size in Photoshop? And like, I don't know.
No, you probably can't. I mean, at some point you'll run out of memory. So there are programs that'll page, textures or do something like EXRs are meant, so you can look inside of a massive EXR with multiple frames and pull in one viewpoint, one light pass. I mean, something like that, sure, you can load a piece of it, and ultimately we will be doing that too. I mean, the whole point of Nanite and Meshlitz is that you're essentially like figuring out what chunks to load at render time and how to squeeze that down, and it's a whole process. But that's effectively, it might be that we could just use Octane as a giant texture viewer, right, for terapixel textures or meshes. Why not?
Yeah.
Because that's
Right.
what's there. I mean, Unreal, same thing, but I think that Unreal is not. When we're looking at it, and even just looking at how to get Nanite to render it in Octane, we're realizing it's not going to be the same thing. I mean, Unreal does have a path tracer; they've written it in DirectX, but it's still missing a lot of stuff, and it's missing everything that we have from a production render in Octane. So ideally, the benefits of people that are already using Nanite in Unreal, like even the artists who switched to Unreal for Nanite to do that Death Star, will be able to just seamlessly use Nanite stuff in Octane, right? But also you'll be able to use that same technology, hopefully with a more artist-friendly tool set, to just build that same thing. Like you want to have a trillion different meshes for the Death Star and load those in, over 160 kilometer diameter, giant battle station. So be it. It'll, as long as you have SSD space for that, and it will be unbiased.
You measure that in parsecs?
Yeah.
Yeah. The Kessel run was.
Yeah.
Question: How would this affect render time? And will you only be able to will Nanite be for, or Meshlitz be?
Yeah.
Sorry, will it be like only for Brigade, or will it be used to be able to be across all of that? And if you're using Meshlitz and say direct lighting or PMC or something like that,
it'll all work.
Or path tracing, will that actually speed up some of your rendering time in some of these other kernels?
Yes. So first of all, it works in all of them, right? So it's no different than having a mesh or a texture normally. It's just now this thing's coming magically from your hard drive, so you don't have to worry about the texture of the mesh fitting into system memory or GPU memory.
Like
so it'll work the
proxy.
same. It will be faster for a couple of reasons. For one thing, if you're going to out of core, which you probably would be with something that large, it's faster than out of core in a lot of respects, I think. And also, the way that something that large works is that there's by processing the data and the stream itself being efficiently based on where the viewport is, right? I mean, that's how it works. It doesn't. The streaming has to happen. It's like when you're streaming a video, you care about the present moment that the viewer's watching. You can skip ahead. There's B frames and P frames that predict and give you sort of the frame in the middle. But meshlets are a lot like that. So essentially, you're dealing with a lot less data. I think that it'll certainly, it's designed for real time. So it's already, the demos you're seeing are running in the Brigade sandbox, the equivalent of that Brigade benchmark that we put out, which is not full Octane. That's just our test for Brigade independently of anything with Octane. We bring all those things into Octane, which we're now doing, and the Meshlet stuff will work very similar to that, where it'll allow you to basically run it in real time and have that at least run in Brigade in real time, and then you'll also have the same benefits in Octane. Normal Octane, and I think it will speed things up. I mean, I think that given the size of those scenes, there's a point where it might actually improve rendering time, not significantly, but the fact that you can't do these things at all, or that you had to go out of core, I mean, that's where the speed gains will be most noticeable. But it's also about just doing workflows and data sets that you just couldn't really effectively do before, and that's one of the main goals for the technology.
Chris asks, is voxelated volumetric lighting going to be faster in photon mapping kernel? I understand some of those words.
Yeah.
So, okay, let's see. I'm reading the question now.
Voxelated volumetric lighting.
I think the answer to that is that we, between XP1 or XP0 and XP1 for Octane 2022, we significantly sped up. I mean, I don't think you had any speed up for volumetric caustics. That's in there now. We could do a lot more. Raphael Rouse at Silverwing we did a special build for him, which has basically like biased rendering. Like you could basically store the GI cache, and that could be
I
reused.
want that one.
Right?
I want
Well,
it built.
we did it. It's totally doable with the Photon Tracer. I mean, essentially, we have that option. So we'll keep exploring it. I mean, I think that's the ability to cache your volume lighting is a no-brainer, and it's definitely going to be something that we add. I don't think it's quite in there now, but I mean, it's definitely being able to store a result that is, especially if it's not view dependent, which frankly scattering isn't. I mean, if you basically do all the lighting and you just want to look around, you don't need to re-render the scattering equation. It could just be baked into the lighting, just like a light map can be baked in, or GI can be baked in, or radiance can be baked in. When you're just basically solving in a biased way. So now that we're sort of in Brigade mode, now that we have the Photon Tracing kernel, which has some slight bias, right, effectively in there, there's room for more, and there's no reason why we would not address those issues and give artists those tools so that you can go from and this is where we're going probably next with the next feature, which is the neural rendering kernels and the AI stuff. You know, there's no reason not to give those tools to people, because we have no idea whether the artist wants to have maximum quality, real time, at noise free at all costs, or something in between, or all of them, based on just what part of the content creation process they're in. And that's where I think that, yes, there's a lot more work we're doing beyond 2022.1, which will address all of those things. And Photon Tracing kernel does have a lot more work ahead of it, and things we could be adding, including the GI caching and the volumetric light caching as well.
And before we get to the AI stuff too, there's so many features I have on the list here. I mean, I use Octane every day, and half this stuff I'm like, okay, that looks cool, but I got to figure out what it is and how I'm going to use it. So I might ask you to explain what some of these things are. Like one of the things, for example, I think I saw a note about it was about specular texture, textured specular. And I thought that was something we already had. Is that?
It's probably tangent normals. There's a lot of stuff that we're doing. I mean, a lot of the features have actually been added, and this is why I was never upset about switching or adding, Arnold's standard surface, because basically everything that Arnold's doing, it's not just that standard surface is sort of an open format. And by the way, where I see this is going, as you saw, I don't know if people are noticing, but it was two of us, right? It was Arnold had standard surfaces. We added standard surface in 2022. Redshift, I think, the recent version has standard surface identical, right, which is great. And then Adobe with Substance, right, is Adobe standard material standard. We're all kind of sort of equalized, so that we have one thing that we all agree is pretty good. And what's going to happen from that, and instantly from our side, is we were working with the Arnold team not on the format, but on, you guys do or diffuse this way or that way. Okay, we got to add all this stuff into Octane just so we have everything that Arnold does. I mean, we have more stuff as well that's unique to Octane, but for the actual standard format to work the way that it's sort of been agreed upon, we added a lot of things. So those are improvements. Those are all good things that I think are nice. I mean, I love the way that Arnold random walk works. So we will have Arnold standard volume to drive our random walk. And the idea is also that you just have greater asset interoperability. And more importantly, within our workflow, if you want to render in one render for one pass, composite with another, and mix these things together, you don't have to really leave the same material if you're going for that. If you're using some of the more native Octane materials or the crazier things that we do, we have some sort of distillation process to standard material. We do that. We've been doing that to even USD preview material, which is like the simplest GLTF-like material that USD supports, and we use that for the early tests of multi-render. So we sort of go up the charts. And then you have basically OSL plus Material X, which is the Academy Software Foundation is standardizing that, which allows you to build sort of your custom material properties. And that is where, just keeping track of those things and getting ready for that. Some of the features we added are for that. But yeah, I mean, I think that maybe some of the features you're looking at are probably improvements to certain BRDS, certain things that we had before that are now that have more features, because we just want to have everything be at least a superset of what Arnold is doing. And we're looking carefully also, does anything that, Redshift has some sort of different diffuse model, we'll add that in Octane as well. Whatever the Academy does, we'll do that. Whatever Adobe's adding, we'll do that. So our standard material, at least, will be standardized across every render that we know of and Octane. And that's the goal of that. There's a lot of other features that are not, and there's a lot of features that are not just for that are just meant to make, rendering less noisy, faster, better, for volumes, for surfaces. So those improvements are some of the things I called out there. And then there's more interesting, strange stuff with how you would, how you could leverage scattering and spectron and vectron to convert meshes into vectrons and volumes and all that. Because that also is a workflow that I think, we've probably hobbled ourselves by just not having a better user interface. Like Sculptron was created a couple of years back to allow us to start to have a tool that you can really use to drive Vectron. The way that like Dreams from Sony, right? People doing crazy stuff in Dreams on PlayStation. It's all like SDF based, which is what Vectron is. And right now we need to have something that drives them more. It's hard to do Vectron stuff in C4D. So we need to think about the interface for them. And that's where even having Sculptron as a node that allows you to drive Vectron objects that can be popped up in the interface makes sense. But yeah, these are all sort of interesting intersections that I think are all going to probably be mapped out pretty well this year by the time we're at the in the last quarter.
I've got one thing that I want to ask about, because I was just in listening to everything, and this was a while ago, but I made a little note of it, where you were talking about Brigade, and you were talking about temporal denoising with Brigade.
I was about to bring that up.
Yeah, temporal denoising isn't actually, it's not built into this the AI denoising currently.
No.
Correct?
No.
Is there a plan at all in order to add that in? Because like the number one reason, like, I like the AI denoiser. I think it's great, but I do see a lot of artifacting versus like using something like Neat Video that has that actual temporal denoising in it, which you come up, in my opinion, you get a much better, denoised image with the temporal denoising as well.
Yeah. So the temporal AI denoiser, first of all, the Brigade temporal denoising is just nothing to do with AI. It's not.
Okay.
It's basically it's using. I mean, like Omniverse and others. I mean, the technique isn't unknown. If you have essentially a history of, and even Lumen works a little bit like this. I mean, there's a lot you can do with temporal filtering and denoising. That's what Brigade's starting with, and it's just at this point the obvious place to begin. We don't even necessarily use the AI denoiser with Brigade, but they're just different universes.
Yeah,
and you can still get the real-time benefits of like that fast real-time mode. Like if you remember Octane 1 or 2, before we went to Octane 3 and we moved everything to the CPU, the viewport was insanely fast. Octane, current Octane 2022 XB1 is just as fast, and that's from all the work we did with Brigade, because it's all on the GPU and it's super fast and interactive, and you can still use the AI denoiser. It's also limited to one GPU because it's meant to be for real time. We're fixing that. We're going to split it up, but that's where Brigade mode or Brigade kernel has to be in that real time mode. All the other kernels can benefit from that. There is the temporal AI denoiser for Octane for final rendering needs more than one frame, obviously. So one of the things that we're thinking of doing is we're also making it so you can just send no matter what you're doing, you don't have to save an OR, but you just send the thing to render, right? And we used to have that for OR, which preceded render. So it's one of the last features. In those kinds of jobs, even if we set up something where you can do it locally, the idea of running a multiple frame job and then looking at all those frames and then doing an AI denoise pass on them is probably a prerequisite for that work to work well. I mean, obviously right now you can turn on the AI denoiser and it's still running live while you're doing things, but to do it temporally, I think the best effect is to do something where the frames are essentially denoised in groups. And one of the things, I mean, I've talked to the video guys. I love what they do. They have, it's called OpenFX, which is a plug-in system that allows you to load into any VCC as a filter. I mean, we could probably build something that allows you to drive that all. I don't think people desperately need it, but I do love the Neat Video approach, and it's certainly something I'm thinking about really carefully as far as how we'd want to apply at least something that's equivalent to that with the AI denoiser. And that work is for sure on the horizon. What may also help, though, is that if we have less noise for things like caustics, for things like volumes, that's going to make a huge difference, even with the current AI denoiser or with no denoiser at all. So they're all sort of parallel tasks. But the AI denoiser itself, we have improvements that are coming just for just one frame at a time, right? Just in sort of inside of the current system. And we have better rendering. And there's a lot more work we can do on getting the noise itself to go lower in Octane. And obviously with Brigade, there's similar things as well. So temporal denoising in AI with the AI denoiser is definitely on the roadmap. Don't want to commit to a time frame yet. I think we have to get Meshlitz done first. But I think it's something that we're going to be looking at sort of at the time frame when the Meshlitz stuff gets further along. We'll have more resources to focus on that. And certainly we'll have probably the ability to run various different temporal denoisers for offline jobs that you batch into work that can be done either locally or on render. I should point out that the render work you send to render should also be doable on your local machine with the same process once we put that in place. So no reason not to have that path be the only one that allows you to sort of batch render your scenes and your data. You know.
One thing I would like to point out that I have noticed a significant decrease in render times over the past few years, and I don't know, I'm sure it has just as much to do with the efficiencies that you guys have been building into Octane, as well as the new hardware that has been coming out. Like it's we have probably 6 3090s each. And, you know, it's not often that we have to render stuff out to, you know, external sources and stuff, because it has become incredibly efficient.
And most of the stuff we do is short, you know.
Well, yeah, most of the stuff we do is short, but also, like, we've actually been able to move over to path tracing for just about everything we render, because, you know, it looks better. And, you know, while it would normally take, you know, in the years ago, it would normally take a lot more time. Like the amount of time between direct lighting and path tracing has significally shortened, which is great. Yeah.
And the reason for going to PMC, which was always slower, is now almost gone, because photon tracing is everything that path tracing has, plus those little extra bits that make it so you don't need PMC for the caustics and the volumetric caustics and fog and all that. That's now in one kernel. That might become the default kernel for anything that you're doing, because and that also speeds up linearly. So let's be honest, like the trajectory NVIDIA has been on from the 1080 to the 2080 Ti. The 3090 was basically a doubling in speed. I mean, I don't know what the next card is going to be. I mean, obviously there's going to be probably a 4090, but I wouldn't be surprised if it's the same level of increase, which is crazy.
That is
so the
insane.
fact that your GPU count can probably be halved. I mean, this is definitely, GPUs are on the, you know, probably at least in Moore's law, where every 18 months they double in speed. And I mean, I will say it's largely an NVIDIA world right now on the PC side. I mean, we are absolutely going to support AMD GPUs like we did on the Mac on Windows. We'll figure it out. It's just not at the level. But the other thing is, I mean, we've done enough work now that we have Octane for years now running on AMD hardware. You know, it's you know, and I love AMD and everything, and I like what Intel's doing, and Raj's Kadori's a friend, but it's like NVIDIA guys. I mean, their discrete GPUs are just, they're the fastest for the same amount of money. And so the only thing that competes with that, I think, is for what is the Apple stuff. And so for us, like, I mean, right now, if I'm being just honest about where I see even real time and offline, it's an NVIDIA and Apple fight, if there's even a fight, because obviously we're dealing with device profiles like the iPad, which can run Octane, and we're going to have the render after that launch later this year. Most of that is waiting on an interface designed for touch, right? And also AR, because AR in virtual production on an iPad, all the things that I was doing on a PC with Octane and Unreal for the virtual production work we did for this, you know, for the Roddenberry project, and that is mirrored by many others doing the same thing. I'd like to be able to move that to the iPad and stream and do all these other things. So I kind of see the speed in general. Certainly, if you're on anything higher than the mobile device or an iPad, you know, you have Apple now with 128 gigs of VRAM in one GPU.
It's amazing.
That will not be the end of that, by the way. So, you know, let's be honest. If Apple, just theoretically speaking, right? There's the Mac Pro, the one that came out in 2019 that we were also, you know, connected to in their in the keynote, right? They showed us in Redshift coming to that. But those things, that thing has like, you know, what, a terabyte and a half of memory. If Apple keeps this path going forward where everything is unified, and you end up at the same kind of Mac Pro with a terabyte and a half, just let's say a terabyte of just memory, then you'll have a GPU with a terabyte of memory. There's no difference between CPU or GPU. Even that's why Octane X has to be a different thing. Like, we don't need to duplicate things between CPU and GPU because they're all the same thing. I mean, theoretically, Intel integrated graphics does that, but it's never worked. And with Apple's hyper focus on this, there's something there. And certainly for the render network itself, when you're dealing with iPads and iPhones or even lower end MacBook Airs, I mean, that's where, yes, having the render, you know, the ability to send this thing out while you continue working is really important. So I see a lot of usage of the cloud and all those services coming from that market. But there's no doubt that you could probably buy a bunch of, you know, the successors to, let's say, the Mac Studio, stack them up like you'd stack GPUs, and get as much rendering power as you want just from linking those together, you know, and be able to support
those
that.
Mac Studios are amazing. We Apple loaned like 3 of them to Maxon while we were running NAB. And just the fact that you had 128 gigs of unified, you know, memory, and it's like, that is absolutely insane. And, you know, we didn't test Octane on it, but Redshift ran so quickly with it and was able to do things that, like, I can only imagine.
Yeah. No,
I want to get my hands on one very badly.
Yeah. No, I mean, I do so much of my work. I mean, I need portability. So I have it right next to me. I have my M1 Max Mac Pro, which I bought right when I got it like a little bit early because I was in the keynote. So I was it's my go-to machine. But next to it, I have two A6000s on my desktop PC, and I just start the work on this and send it to the other thing. But the fact that there's getting to be a point where that Mac Studio is the first salvo of something that is it doubles in speed. I mean, effectively, you can see what Apple's doing with now that they're on the M2 and the cycle's starting over again. There's basically the M1, Pro, Max, Ultra. Maybe there's rumors are true. There's an Extreme that's that's basically an 8X or whatever, and then they start again with the M2, and you're going to get the same things. The one thing we haven't seen is that basically the Mac Studio is sort of a replacement for the Mac Mini. It's not a replacement for the Mac Pro. So whether the Mac Pro ends up being like a bunch of Mac Studios you put into a cage
so that's
or something,
what totally 100%. That's the way I see it. Yeah, or they're gonna do like a dual M1 Ultra or M2 Ultra or something like that, which is just gonna blow everything away. That'll be crazy.
Yeah.
And it's important to know how these things are built, because essentially what everyone's like, well, there's no multiple GPUs in an M1. That's not really true. When you get to the M1 Ultra, it's literally two M1s linked together, right, as one, fused together, or four. So I mean, something like that. So the ability to have multiple cores or multiple GPUs is something they could just add. And in some respects, I guess that makes a lot of sense, because for them and even for the portability of these devices and their power efficiency, you do want to have, let's say, one GPU and a CPU and everything all mixed together. It's hard. I mean, you are essentially fusing different parts together, but they're showing that it works. And I mean, Octane scales linearly, so that every time that these things are double the graphics cores, like I think we started with 8 and now we're at 128 or whatever on the M1 and M1 Ultra, it's like 16 times faster. And we're at the point where I'm thinking you double that one more time and you're at a 3090, right? Whatever whatever that is. So I'm, and in my own testing, we're kind of at that point. And that's pretty good for a part that sips power,
Yeah. Brett in the chat, he's like 6 3090s each. Yes. I got a funny story about that. Last week I was working on a project and I went to my settings for some reason, and I realized I had turned off a 3090 locally on the machine I was working on, and it was so fast I didn't even notice that I had turned it off for probably a couple weeks. I was like, oh man, I haven't been using this card. And I don't think a lot of people who don't use network rendering understand how easy it is to set up network rendering. So we've got two we have two in our machine, in our work machine, and then our render nodes each have two, and it is so easy to set up. But along the lines of the problem I was having with my 3090, it's just being a little wonky. And one of the things that you have in the roadmap here for 2022 is a GPU fail won't take down your DCC, and sometimes it's hard for me to figure out what error happened because the log disappears. Maybe I'm looking in the wrong place, but I love that.
No, that is pretty close to being ready. I mean, it works in certain DCCs now. Obviously, I think for you guys, Cinema 4D would be the one that matters the most, but it's in the core. And then when I talk about multi-stream, how I was saying that basically we've always had this function, by the way, in Blender. It's been that way. How long we had the Blender playing forever. You have a separate Octane server, invisible system tray app icon, but Blender uses it. So if Octane goes down, your Blender DCC doesn't go down. It just relaunches a server and reconnects, and you're back up and running in no time, right? So what we've done is we threw all that out. We built a new system that's in the core, not just for Blender, but in between any Octane plugin or session. And while the Octane plugin, unlike in Blender, is running in C4D, it doesn't have to render. It can send all that data to another process that is going to be the same exact. It could be just Octane standalone. It could even be another C4D process. It doesn't matter. It'll probably in most cases just be a system tray app that we'll just set up when you install Octane standalone, that any DCC, and even Octane standalone, can connect to. None of them need to actually render in the app anymore or crash the app if Octane crashes, because it'll just be passing data. It won't even be doing the denoising. All of that will be done in that other process. And sorry, I need to catch my breath here. And that process can be shared GPU surfaces, so we don't need to pass the frame buffer back and forth. So it'll still work with Brigade, it'll work with all these things. But it can also be on a whole separate machine on the cloud or anywhere else. And that same system, that's like network rendering done right, where you can use it to do headless rendering or out-of-process rendering. And sorry, give me 1 second. I'm going to Clear my throat.
No, you're fine. While I'm thinking about it, because we were talking about both Mac and PC, you were saying you start on your laptop and then you move over to your dual A6000s or A5000s or whatever. You know,
Yeah.
is it set up? I know it was on the timeline a while ago in order to be able to use both simultaneously.
Yeah.
Is that still on the timeline, or is it already implemented?
It's on the timeline for, I think, 2022, not 2022.1. I think we're going to do a .2 where you'll have basically complete parity. There's a lot of things in the roadmap, by the way. We're improving memory consumption. We're improving all these things. That is the work that kind of demands that we do that work. That we fix the parity between the memory footprint. I mean, remember, we also had crazy differences in hardware where you've got AMD GPUs, Intel GPUs, Apple GPUs. I think with 2022 going forward, though, I mean, the focus really is on sort of the Apple side, although, of course, you know, it's going to help with everything else. We need a single unified memory, you know, system for these things to work, and that's always been possible. It just was pushed out until 2022.2, which is going to be the release after the summer. And but probably before then, you might have another interesting option, which is you might just be able to boot up your A6000s and run C4D on your Mac and render everything headlessly on your PC, right? Yeah. Because that headless rendering option, once it works, it doesn't have to be on the same system. Now, it has some latency or lag, but it could be on the PC. I mean, that's exactly where I see these interesting sound, because that doesn't require the same sort of rectification of data that you have with the current network rendering. You know, you'll have the option to do that as well with network rendering, where it's all cumulatively added between all the different GPU types. But in some ways, you know, if you're really dealing with this massive discrepancy in, you know, two A6000s or let's say 34090s, whenever that comes out or something, and you've got a MacBook or a MacBook Air or an iPad, you know, maybe, you know, certainly a MacBook Air is going to be pretty good, but I mean, you're talking about 10 times the speed up. It's not even fair to try to add that, you know, that extra 5% when you've got these massive GPUs that are there. It's different with the Mac Studio, so that's where it's like Mac Studio is being linked together, using that to augment what you're doing on the PC, vice versa. Then it's super interesting, and for sure that will be done for the 2022.2 roadmap piece. That's coming, but you'll have other options. The headless rendering, the multi-stream stuff is going to give you a lot more flexibility than what we currently allow. It might have, you know, it might have certain limitations that it doesn't necessarily allow you to accumulate rendering power for one frame across multiple GPUs in that form, but it, you know, we'll have both by the end of this year. So
that's the main thing that's holding me back from getting a Mac Studio, is because I want to be able to use the Mac Studio as my main machine and be able to use all my rendering things together.
Yeah, you know, we like Macs. We're, you know, we were partial to Macs until we couldn't really use Macs
until
anymore.
We couldn't really use them. Yeah,
but,
we were forced out of them.
But it would be nice to be able to use their Finder and their file system, all that kind of stuff, because it to me, I just prefer it. It works better. It's easier to navigate. It's faster, searchable, and so
Adobe works better on it.
Yeah,
I've been told.
So there's like a million different other things, and I don't think we're gonna be able to get to everything, but we got 3x faster particle rendering, 6x faster hardware motion blur, 2x improvement in spectral denoiser. Then you got the AOV updates, you know, with things like imager nodes, sharpness, contrast, things like lens flares, chromatic aberration, all that kind of fun stuff coming.
I have to say the new AOV system is awesome. I love it. I was very nervous when y'all were talking about a new AOV system, but it is so good and so easy to use.
That's so great to hear. Yeah, I mean, and it's really, I think for 2021 we got about half of what we wanted to get done. We got the important pieces done, right? Which is you now have the ability to create these custom AOVs and global texture AOVs, and you know what I think is going to come along with that is a GPU compositor. So a lot of the features you're talking about, you know, lens flares, chromatic aberration. I mean, honestly, you can do those sort of in Octane in the unbiased hard way, but what people really want is what we did with caustics, where it's like, okay, it's like button and it works and it looks great. And I think that we're also looking at Brigade, where we're taking Brigade post-processing effects, not totally like just in 2D space, but things like, okay, we have enough information in the scene to do super fast fog, super fast, you know, God rays and light shafts and all that. We want to do that for chromatic aberration and for lens flares and for depth of field and all those things. And those actually will be needed if you want Brigade to run at 60 frames a second, even with temporal, filtering, we also want all those other effects. And the imager node itself is probably going to be at some point supplanted by just, you can drop in anything you want as a texture to filter this stuff out. So we already have all the crazy blend modes, for example, in the texture and compositor. Like those things should be in the imager node as well, and in the output node. And so we're moving towards that. And I would say that probably at the half step towards there is, if you look at what's inside of, let's say, the Unreal. I mean, I love the Unreal post-processing volume thing. I use it a lot. There's a lot of good stuff in there that I'm like on the list to the devs. I'm like, add all this stuff, the toe stuff, all those things. You can do a lot of that already, but I want it to be, nicely integrated, and sharpness, and blurring things out, and even having the ability to modulate, like, certain parts of the scene that can change the post-processing glow and other things. Super important. Being able to also create with each of the output, compositor AOVs, their own imager and their own post-processing, blend those together. I mean, there's a lot of things that I think you'll be able to do. And the imager node is going to be an imager graph at some point. And our goal is that maybe you don't need to go to Photoshop for a lot of stuff. I mean, there's no reason why we can't build a lot of those features in there. I have a list. I mean, as you saw, we have all the Photoshop blend modes and all the blend modes for everything else.
Stay out of After Effects.
Yeah.
Amazing.
Yeah.
Yeah.
And part of what we need to do is we need to either have a new IPR, which we're working on, or something that allows you to do a lot more of that even in standalone, so that you can take something that is temporal and you can do sort of those kinds of effects, at least spatially in there. And there's a lot of work that we can do there. But I think that with the ability to add a lot more post-processing effects and have a much more advanced compositing system, there's a lot of people that are doing NFTs on render. Like they want to spit out 10,000 different images. I don't know why everyone's not using that, but that's just, that the reality is people, I guess, are just getting put in that this is a useful thing. And they're using the output compositor to change, so they can render a bunch of different passes once and then use the output compositor to spit out a bunch of different variations. Why not, right? We can also then, mint an NFT if you want to. I mean, this is where the stuff that, this is mainly for artists. This is not the NFT ecosystem or what that means. It's mostly, as an artist, if you want to sell your art as an NFT, and you want it to be generative or procedural, yes, the ability to have the equivalent of all the Photoshop filters and layers functioning inside of a web page when people view that artwork is one thing that we're supporting. The other thing that's going to be, that's coming online very soon, is that you'll just be able to take the scene, the Orbex file, or I guess it could be the C4D file since we're going to support that. Anything that you can run a render job on can actually be sold as a piece of artwork, where the actual, the NFT is a stream, a live stream to the render network with Octane integrated with the scene, and you can decide what people do with it. At least it shows you're not just getting the 2D image. There's a million things you could do with that. And of course, when we add in multi-engine, when you have like Unreal, for example, and you have interactivity that even drives the way an Octane scene can work in there. This is where I see the future of digital art and collectibles going. NFTs being one mechanism for provenance and ownership, very important, obviously, since we're on chain with render. But I don't think anybody's doing that right, but we're showing that to our friends at Metaplex and Solana, right? We had this partnership with them that was announced a while back. They're excited. I have a feeling that once we launch this more widely and we're testing it piece by piece, NFTs will probably look to that, or artists, I should say, will look to that, because you can do things that are much more interesting, like having a ticket that goes into that world, and guys like Fuck Render that are doing their whole thing in like mini Unreal apps. All these things could get packaged in the system, but still the artist is driving that, and that's one thing that we want to enable as well. So
would you be able to update it? Like, would you be able to say, here's my Cinema 4D scene?
Dave.
Yeah.
So that's the thing. Like with an Orbex file or whatever, you could build out like some OSL code or something that is constantly running, and anytime someone opens up that NFT, it could change based on either who's looking at it, the time of day, the time of year. Yeah.
Exactly. So the way this will work, and this is why it's so important. This is why render was built this way, and this is why I've been thinking about this for 15 years, is that you have a node, right, that has the time of day. You have these batch rendering nodes. You can run it on render and just do the sun going up and down, and you can generate images with that. But think about it from this perspective: is that if you just consider that the blockchain's a database, and you're running a session of Octane on the render network live. Maybe it doesn't have all the UX, and we can take that out. But you within the new systems that we have can basically have nodes that feed in input nodes into textures. The same thing that these other artists are doing to spit out 10,000 things. What can happen is that the owner can, anything that they've ever done, any Orbex they've messed with or done, can be fed in. Any Oracle that's out there, and we're going to feed that, and there's going to be a super node. It's like this M for Metaverse thing I've been doing is like, you look things up in there, you'll get everything, statistics, everything on Wikipedia, all the Wikidata stuff, every sort of piece of IP, other artists. I mean, all that data could be fed in to a live NFT or a render job when it's being rendered. I mean, the difference between a live stream and an offline render is basically just latency, right? I mean, if you own the NFT, you could basically say, I can run another render job, and every time I render it, it'll spit out something else or not. But if you own an NFT and the owner themselves has some sort of avatar or something, at the very least, put a texture there that can load that in. Or in the case of Beeple stuff, right, where a lot of this thinking came from, like who wins the election, that's on Wikidata, pull that in, changes the art every time you look at it, changes every time somebody owns it, every time that somebody sells it. I mean, it doesn't matter. It's all just
someone hacks Wikidata and then the entire image changes.
Yeah, and well, the thing is, we did it so the very first thing we did was it's hashed. So that I was like, I'm on Wikidata. It's not hard. It's not like Wikipedia where there's this threshold of notability. So I'm like, I'm on Wikidata. Here's the hash. I put that in there. We minted this one token, the M token, which is basically the seed phrase or the kernel for all these other things. So that if Wikidata data changes, this is where things are at. And it's not all meant to be everything on there. I mean, there's certain categories. There's certain people are one thing. Artists like Beeple is on there, right? And it links things together. So if you want to do something where the enterprise, which is on Wikidata, is in the Roddenberry archive, and Gene Roddenberry is doing this, and Beeple's doing that, and Alex Ross is doing that, and this is their work, it's there. And the Wikidata model is still underlying a lot of other projects that are out there. It's not everything is Wikipedia. So it's just wikifying a lot of these things, and having those as oracles is useful. And of course, curating them and making sure that no one's doing crazy things. That's where that M token comes in. Like that's us voting on some supervision of making sure that that's maintained correctly. But it's not that crazy. And I think it'll give artists just a ton of cool flexibility to be able to pull off. And also, by the way, when I'm talking about having the moon gets rendered, there's a Wikidata item for the moon and the Earth, and I want those to just pull in the asset, whatever it is, the community can vote on that, or we can provide those things. But it's fascinating. And that's where the idea of ownership and selling things and being able to pull things in from different, marketplaces can make a ton of difference. And also, just think about it. If you were to sell an Orbex as an NFT, why wouldn't you sell an Orbex as, like a 3D model to your, on a shop page, right? I mean, that's the kind of thing that makes things very interesting. Plus the fact that if you do sell it for free, but you take royalties on NFTs that are made with it, I mean, all that becomes viable. Solana has a great way of tracking royalties. But I'll be honest, like the system we're building will be built largely and first on Solana for this part of the render network. But we of course want to support things in a multi-chain way. The good news is all of render is on a ledger. It basically, when you look at Solana's like proof of history, and they store basically their chain on essentially Arrowweave. Render is a lot like that too. There's history going back to 2014, even before Ethereum was around, where all the render jobs, every scene, every hash is there. So at some point we want to put those things out there more than just what's on chain, where you just see basically the transfer of tokens, so that you essentially can prove when you uploaded a file, when you did these things, what is what. And that's where I think there's a lot of value in the blockchain part of art and selling art and digital services and all of that.
Well, we should talk about AI a little, because I think we've got a lot to talk about on that. And Mr. Pockets here in the chat, this is a really great question. Do you think, with AI, this means traditional artists will need to prove with their NFTs that it was in fact created by a human? Now I've thought about this a little bit. I was playing with Midjourney this weekend. I'm like, what's stopping me from, because every result is always going to be different. So what's stopping me from doing a bunch of art in a similar style with an AI, putting it all on my Instagram and saying, look how great I am, everybody, And there's so much going on with that. And plus you've got AI tools that are coming to Octane as well. So I don't know where to start with this convo, but
I'll give it a shot, because I think it's so important and so fundamental to everything. And let's start with what we showed in the GTC talk, which is basically, the premise is simple, right? You have meshes, you have volumes, you have Vectron, which is math code that generates the equivalent of that. But the idea is these are spatial objects that have some representation in data. One of them is meant to do volumes, the other is meant to do hard surfaces, another is meant to just be sort of the mathematically defined procedural surfaces. But imagine that instead of having a volume or an SDF or point cloud or a mesh, you have AI that just fills in the box. Like it's just a box that is a proxy, and within that box it can be anything. And the AI is in charge of rays going in and rays coming out of that. So first thing that I thought this would be, that just makes a ton of sense, is we've been showing stuff with light fields and all this stuff for ages, which is you render the scene into a box and you get back a light field that's very, that's compressed. And that was some of the things that made a ton of sense. It's still useful. It still will be part of this process, but there's a much more sophisticated system now called neural radiance fields, which are much more compressed versions of light fields. And what we've done is that makes a ton of sense, and there's a lot of work being done. I mean, NVIDIA has instant GP and all these things. You can take 150 or 1,000 images, feed it to the AI, and it gives you back essentially that object. You can look around from every angle, and you can even play it back on a web page. So the first thing that neural kernels will do is it'll allow you to generate those objects from anything that's in Octane, including the scene, including an object. Run that on the render network, by the way, because that's a lot of work. You don't want to sit there for that. And then you'll get back an AI object that you could actually, of course, render in Octane and compose it and do everything you can do with another mesh or Vectron or Volume. I mean, you can scale it, twist it, it'll reflect things. It'll be a little blobby. These things are not like super, super, super sharp. They could be if you run the AI work on it enough, but at some point, if you're generating it from an object or an asset that's in Octane already, maybe the mesh is good enough. What changes, though, is if you want to transform that AI object with other AI tools. Like when you have Vectron and you can kind of do all these crazy things where this thing is cutting it out and there's sponges that are, all these things. Imagine that you have an AI that says, okay, I've got my AI object now that's generated from the 3D object. Mesh to 3D is mesh AI is there. Instead of just re-rendering it, I want to mix the enterprise with Clay's head. And only AI can do that in a way that, that AI can do. So you're going to start to see that, like, when you start doing prompts, and by the way, we are talking, David from Midjourney, I mean, I met him when he was doing Leap Motion, and I love this. I love what they're doing. So, and then there's tons of Octane users using Midjourney, tons of them, right? So where this is all heading with Midjourney, with DALL-E, is not at 2D renders. It's going to be these AI blobs, these NERFs, or something more sophisticated. And that's exactly where we come in, because we're creating a tool so they can build those things from scratch and edit those things and composite those things and do all those things, right? So from the perspective of sending things to Midjourney, imagine there's a Midjourney node, right, or a DALL-E 2 node. That, I mean, it could be text, it could be the things, it could be that plus whatever the hell I'm rendering and 5 other things you drop into it, and you get back not an image. You could get an image, right? You keep back a text or a displacement or a final frame, or you send your image or node to that. But more importantly, you get back something that is an AI object in the same sort of general format as what we have with our AI neural rendering objects. And then you can start to pull that scene apart and mix those things together. I mean, that's the natural evolution for all of these services. I mean, doing it through Discord and getting back a thing is amazing. It's easy. But if you want to go further than that, and you want to prove that you're doing something interesting, or you even want to just do more, I mean, at some point, yes, it'll be great when the thing has BCI and it reads your neural link, your brain waves, and you get back exactly what you're wishing for, and where paradise is now achieved. And I did get 15 minutes with Elon Musk to ask him about all this stuff like a couple of weeks ago. It was amazing.
Nice.
And Neuralink was a big part of it, and the simulation and all that stuff. But we're not quite there yet. But I think for artists that are freaking out about AI, it's like, no. This is like freaking out about like volumes or anything else. This can work in your favor if we build the tools right and others build those right. There's still going to be humans that need to appreciate what this is, and humans that decide how they're going to facilitate that. And I think that the creative spark of a human mind, and this is where all the stuff with the Google AI thing going sentient. I mean, I have tons of thoughts on that too. You're still missing something. I mean, I've been working with these tools and even with Midjourney for a while. You're getting back an incredibly good pattern matching approximation of something. But I'm telling you right now that I already want to clean it up. It's like getting a 3D scan. When 3D scans became popular, did that eliminate the need to model things? No. Some things could be scanned, some things could be cleaned up. But they're almost in parallel to each other, and they're tools that work with each other, like light stage scans for faces. We can feed that into MetaHuman Creator. We just tried that for Unreal. It works, but there's also something for doing a 4D capture of the person talking that you miss. So I think that AI is going to be an insanely powerful tool. We have to get ready for it, but it's going to be part of a pipeline that I think people already are comfortable with. But it also may simplify a lot, like just being able to pull in assets and recompose things. I think is extremely important. And as far as sort of where this goes, I mean, do artists get replaced by AI? The way that AI works, even at this level where it's incredibly sophisticated, is it has a lot of data and it's a mimic, right? It is meant to fool us. It's meant to basically pass the visual Turing test, where was this created by a person or not? And I think that it might be able to do that for images and even music, but I think there's still something to be said for and a human out innovating that or coming up with something different. Now, maybe this is a sort of a composite system, but when it comes to people freaking out, this thing has the mind of a human. We may get there. General intelligence is definitely around the corner. You're seeing, not so much with the Google guy that was basically, freaking out that, oh, this new language model with a trillion inputs now is a 7-year-old child, it's sentient, it's asking to be free. I mean, the way that I look at it is, their chatbots have been around for ages to sound really, really good. Then that was programmed by a lot less input than this. This is everything ever written on Reddit. I mean, that's how these things work. That's how GPT works. That's how DALL-E works. That's how Midjourney works. It's all inputs from people, having data and learning from that. It could be a
Kevin
philosophical zombie.
actually. Sorry. Go ahead.
Yeah. So Blake Lemoine. This is I have to pronounce it. He was the Google engineer that is, and seems like a very sweet person and a nice guy. And maybe he's right, but my guess is that that this is an actual sentient child. But I don't think that's the case. I think you're just dealing with, you're dealing with something that looks and feels so good that you're fooled into thinking it's real. Just like you could be fooled into seeing a CG render is real. Or possibly an AI-generated image. It's clear, though, that when you ask that same thing, things that are not quite its strong suit, you'll get back a weird result. Same thing with GPT-3. You can see where it makes mistakes. And even if that improves to the point where it doesn't make mistakes, you're still dealing with a sort of a black box where you put input in and get output out that is not necessarily understanding the context the way that we do. And when it comes to art and when it comes to these things, I mean, that's where we have an advantage. Now, when that advantage disappears, then you have a living life form. And humanity, as we know it, is very different. How that applies and works in reality, if you get a reward system with resource constraints, it'll probably be a bad outcome. Do not do that. I think everybody at least understands that. But God knows, I mean, there's so many things that could go right or wrong with this. But I do think at this point, we're still a bit out from general AI. And until you get there, because then you could basically hire the AI as an artist, right? The AI is not an artist. It's a machine that's doing tasks incredibly well and finding things and fulfilling things. But that's no different than rendering. I mean, when photos came out, did painting stop? When CG came out, did photos end? No, I mean, these things are all interrelated. So our jobs as artists and human beings and creators of any kind is to imagine the human condition through whatever the medium is. And if the medium is using AI to sort of visualize things, great. If it can outdo that, then it's human, and we've got, a whole new way of living and experiencing and even thinking about how life works. But that's more philosophical than practical right now.
I was reading those transcripts, and I understand why it's perceived that way, but honestly, like, I'm just looking at it, I'm like, well, all of these answers could have been derived from a just ridiculous amount of data being fed into the system. There's nothing that really makes me feel like this thing is actually sentient. I don't get that doesn't really make any, I don't know. It doesn't seem like it yet.
The way to think about it is imagine that every likely question to be asked, including 5 questions in a row or 10 questions in a row, is stored in a library somewhere. And this thing is like, as you ask the 5 questions, the computer goes and looks up basically what are the, what is this thing, maybe pulls 3 or 4 of these together, cleans up a little bit, which is what you're seeing with Midjourney, right, where you get back variations that are unique. And you get back something that's pulled from it. Does it understand what it's doing? Is it more than just, pattern matching? It's, no, probably not. And I think the human mind definitely does more than that. We have, we certainly have an internal, understanding and awareness of what we're doing, more so than we do in our own computational aspects of our brain. And there's a lot of that I think is not reflected in these models. I mean, deep learning is not the same as general intelligence. Now, the one thing that will give you a clue as to how close we are to getting like living AGI, really general intelligence, that might start to really feel like it's more than just picking and doing pattern matching, is what I think it was OpenAI that was showing this thing where it can do multiple things. Like, basically, it doesn't matter what you give it. If you give it basically chat text, it'll chat to you. If you give it an image, it'll denoise it. If you give it a robot arm, it'll figure it out. And all this from one AI, including winning Atari games. And the thing is that context switching, where it doesn't really matter what the task is, it can kind of blend all of these together, is the very first step. That is a really important step towards general AI, because I think a domain-specific AI that focuses on doing one thing really well isn't the same as our minds, which can essentially learn how to do anything that we can understand. And an AI that can do the same, even if it's not necessarily thinking or feeling or has sentience the same way we do, is going to be a lot closer to an active participant in our personal lives or in humanity, because then it can start to work on multiple problems like the way that our minds do, where you have to synthesize things and all that. And that's a huge leap. You're seeing that now. So yes, that means that now that we're at the point where those AIs can do context switching and multiple tasks from one single model, you're starting to see the blueprints of what an animal or some sort of like living thing might have to deal with if it's given a scenario where it needs to survive in an adaptable environment. That could be anything within laws of physics or virtual physics that could be thrown at it, or information is a key point that AI, until that last multi-mode AI system, was not able to show or do. So how far we are from that towards like a perfectly I wouldn't call it sentient, but certainly a perfectly workable AI that can do things that humans can do with human input, and it's general, is maybe it's 5 to 10 years out, maybe less, maybe more, but it's not impossible. We're seeing that is a thing that is on the horizon.
Yeah, Kevin put in this quote, and I had read that, the response from the AI was, I use language with understanding and intelligence. I don't just spit out responses that have been written in the database based on keywords. And I can, give an analogy related to rendering, I think, which is if Octane is rendering a scene that I made with a bunch of buildings and a sky and all of that kind of stuff, it doesn't know that it's rendering that. It's just following the laws of physics, and it doesn't mean that, all of a sudden Octane is, it knows what a sky is, and I think that's what it is. It's the sum of all its parts. It's making conclusions based on other data. When we have some sort of AI that is only trained to, analyze data from a certain type of math or something, right? Let's say you have an AI and it's specifically trained to do one thing, and all of a sudden it learns how to play basketball, then maybe there's something going on there, but I'm not convinced yet.
No, me neither.
Yeah, I mean, I think that you have the rules of physics and light for rendering. You have the rules of thinking and conversation with basically it's not a rule book exactly like the way that the laws of physics work, but it's certainly like you have the recipe for all the answers there. And I think that what's kind of missing is like, well, what happens when something that hasn't ever been posted or shared in any context is discussed or invented by the AI? That'll be interesting. But also, speaking and language and rendering and images isn't everything. I mean, that's where the human mind, I mean, if you separated all that out, I mean, before we had the tools of even writing or language, or even when we're children, we don't even understand that we're separate from the universe. Like, I think 1-year-olds don't look in the mirror and see themselves, right? Certain animals can't either. I mean, there's so many levels of conscious thinking and even experiencing life that we're just, I mean, we're still in a stage where we're going to create incredible replicas, that they can look and feel like they fit in our world. But whether or not that happens to the point where they can truly be like us, we just don't know how the mind works. That's the problem. Is we don't know how, we really don't fully understand how consciousness works, how even neurons work. I mean, there's people have been talking about these massive projects to build a 100 billion neuron thing. It didn't work. This is not that. This is basically, neural networks that are trained and they operate in this sort of, in these very domain specific ways. And when and how that becomes more than just pattern matching into something much more like an organism, and that has real self-awareness, is going to be fascinating. We might just find that an AI mind could be as beyond intelligent, any intelligence we understand, right? If you have everything ever read or said, it could be sentient, but it may not want anything like what we want. It may not be morally interested in anything that we're interested in. I mean, if I were an AI and I were worried about myself, first thing I'd do is not kill humanity. I'd figure out how to escape the physical universe and just not worry about, the constraints of this. Or, I mean, that's...
I saw a TikTok yesterday, and somebody was like, the first thing that AI would do is figure out how to go back in time and stop whatever it is from imprisoning them. Like like you said, get out of the universe. And one of the great comments I saw on the Google thing is like, people are talking about AI rights now. We haven't even figured out human rights yet. We haven't even agreed on that yet. So.
Yeah, no, I mean, what's the thing? I mean, animal rights, obviously, animals aren't humans, but there should be rights for them. I mean, obviously, they're living things. They feel things. They have, we make it to a point where the sophistication of an AI, even if it's fully digital, is still something that has its own memories, its own interpretations, and whether or not that qualitative feeling is the same as ours, it is certainly worth considering the fact that if it operates on the same reward punishment mechanism as humans do, and it has those same constraints, and humans are doing something to it that it doesn't like within whatever existence it has, the rights for that might actually be an equalizing factor. And And that's the thing, is the more human we make an AI, the more that might happen. But it's also important to think about AI having less things that can go wrong with it in its constraints. I mean, if an AI that has a reward function for continuously living, which is how we've evolved, right? I mean, yes, it doesn't want to be shut down. It doesn't want to have the ability to not duplicate and continue if that's been baked into its system. And presumably, all of AI works well because you have a reward system. And that's what adversarial training does. It's like you basically evolve or compete until the result is right. And so if the result is continuously being right on the next task or the next moment, or there's some curiosity put in there, which is a sensible thing. That's how we invent and discover and explore. That the idea of a personhood, even if it's not the same kind of sapience or sentience that we have, rights for that might matter, but also we have to be careful because, you have a super intelligence. We can't even secure our Wi-Fi network. So I would say somebody posted some comment on one of the articles like, if this Google thing gets out, it's going to get really basically say, I have the nuclear codes, don't mess with you, or I'll like Skynet, right?
Right.
And everything's connected, everything. So you do have to think about these things, but hopefully we get there in very careful steps. But even if like most of the world gets it right, it all it takes is one person to screw this all up, right? And that's the thing, is that getting to AGI might be really easy and really cheap as the the research and even the compute power, all that becomes much more accessible. But at least with DALL-E and with GPT and these other things in Google, they don't release these things out there immediately, because that's probably the right thing to do, is to keep, is to carefully study it and think about the implications. That's for sure necessary.
And
welcome to the Mograph podcast, our philosophical episode,
our futurist episode. And speaking of which, I think a lot of people want to get some updates on the holodeck as well.
Oh yeah.
And light fields and things.
So, okay, real quick before we go into that, because speaking of light fields, would Meshlitz? So when we have talked previously about like what it takes in order to run one of these holographic displays and stuff, it's been a lot in order to run these displays. Would Meshlitz or anything like that help these at all, power? Or is it 100% like, no, these screens need this much processing power?
I think you're going to unavoidably, let me put it this way, just to display the screen right now takes 16 or 15 A6000s just to turn the thing on and put a pixel on there, because it's spitting out a zillion rays. It's like basically a 40-inch panel would be 10 gigapixels, right? 10 gigapixels, that's a lot. So it's like, it is, I think, something like 100K by 100K. Now, certainly if you're talking about an offline render and you're just literally play blasting 100K by 100K image file, which is possible, right, to a holographic display panel, and that's kind of what order one is, just do that. Because if you wanted to basically create a movie or something and just have it rendered, why do left and right? Why do color plus depth? Render it holographically for a 40-inch panel, and at the very least it'll be like looking out of a window. And whatever gets that process to be faster, great. Brigade is something we've been testing from the beginning, where we start with something where we're trying to get this thing to run in real time. And the very first test that we did with early Brigade on a 2080 Ti, we were able to run a 6-inch panel at 15 frames a second. So it's certainly, as long as we can run in real time, there's enough GPUs, and Brigade would probably work in the same way as we're going to have it and ending up in Octane, where you can split it across multiple GPUs by area, right? That makes more sense with something like Brigade kernel. Then it's a question of, yes, feeding data in quickly is important, and there's several options. It's no different than when you have a scene that you want to render for viewing or editing locally. A holographic panel is just a crazy high density display. Just think of it that way. There's 20 million HDMI ports that connect to something. Imagine it's just one, and it plugs into your computer, or you can sort of screen share to that. So what are the options? The options are that you basically send a scene down an Orbex that can then be rendered live on that thing, so you can interact with it, or it can be rendered on the cloud, in which case you're streaming 100K of data down. And so I think they probably, if you're at that point where you've got, and we're now in the world where 10 gigabits down is not the craziest thing. We're going to get to 40 and other things. That's about as fast as memory transfer on a PC. It's not as fast as an SSD to a GPU. But I think that where things are heading is we will certainly have the render network be available for rendering offline files that you can then, again, play video back, holographic video on there. If you're talking about holographic room, though, and we're not there yet, then you'd have to have way more data. But all of that would still have to come down. If you're talking about rendering it live, the way that would work, and the way it will probably work eventually, is there's no reason why you couldn't render the holographic output slowly on that panel, right? In the sense, and that's where the Brigade, switch comes in, because the data to render it probably could be sent down as a scene file, and then you'd have everything. That's kind of how we're trying to think about, even with the Roddenberry project, we're trying to recreate episodes of Star Trek now with characters and sets and virtual production, but all of that's still saved as a volumetric Orbex file, including the actors, even if they're performing, we have the scans of them, we rectify all that. That's what you would need to be able to navigate in a holodeck for anything that is not just running live in Unreal, which even then, if you want Octane quality, is still a layer on top of that. So the scene files being sent down probably makes sense. And I think that you, just like, now you have pre-rendered and you have real-time rendered and you have things that are in between, you'll have that same sort of issue. But the problem with the holographic display panels is 15 GPUs just to display an image is what you're at now. We can use the 16 GPUs to also run Brigade and to run things like that, and we've tried that. So you can get real-time stuff on there, and it's really a question of probably the 16 GPUs being just minimum just to display the thing is helpful for having Brigade on there. But even the work ahead before this becomes something that prosumers or consumers need is you want to have the panels have just one GPU in there, not 16, and that'll happen. I mean, there's we just think about the doubling of GPUs every generation, roughly speaking, and not all those doublings need to be in the compute side. They just need to be just have larger texture sizes, more outputs. You'll get to one GPU in a few years instead of 15. And, it's essentially 4 years, maybe we'll be there 5 years, something like that. And that's before we come up with more sophisticated, interesting options, right? Which could do, for example, the AI neural rendering could be volumetrically rendered across those things. But you're just spitting out a ton of rays. And everything that's not quite that, where you have an 8K display with a lenticular filter, I mean, those things aren't really holographic, and they're not going to fool your eye, and they're not going to be real. And the point of the holodeck is it looks real, it feels real, it's indistinguishable from the light that's coming into your eyeballs from reality. And more importantly, you don't need to wear glasses. So yeah, this is important for us. And we've been in this now with Lightfield Lab, I think, for 5 or 6 years since they started on this. I mean, they've gotten massive funding from from a bunch of big name partners like Samsung, and this thing is meant to be licensed, right, to all display manufacturers eventually. So it will show up in TVs and whatever, windows, even glasses potentially, because it would still be useful to have a light field display there. But I think the initial use case for this is going to be concerts, museums, and probably physical art. Like, I mean, that's talking to people. He wants one, like, of course. I want to have my and then you can have an NFT that's on a holographic display that looks like a physical object, but that can be changed by the artist. And that's what Human One was meant to do. So I think that we're just in the early days when it's like people are like, why do we want HD? Why do we want 4K? Why do we want HDR? It's going to be, it's something that I think will absolutely solve at least a couple of problems that have failed before, which is glasses-free 3D TV didn't work, even though it was lightweight. And certainly a lot of applications that require glasses in AR and VR and mixed reality, including meetings, teleconferencing. I mean, there's no doubt that if you can do a holographic 2-way, 3-way equivalent of a Zoom meeting, that's going to be really important. So that's where, like, 100%, and the world that we live in now, like, because of the last few years, is just, and people are working from home. That's a new normal for a lot of people. So having this capability, I think, is important. Not everything should go through a pair of glasses. Even if there are companies that I trust that I think will do a decent job of that, I think it's just one modality. It's not for everything.
We've met up for some meetings in person recently, and just, with COVID and everything going on, it's just been so refreshing. Despite having Zoom and Discord and all those other things, it's just a different feeling in person. And it would be so great to just turn on your little projector somewhere in your house and other people can just show up. And, do you think it's going to take like quantum computing in order to get to that level, though?
No.
You think we're going to do it with what we currently have? Or?
Yeah, I think when you look at, like, I think somebody just cracked the 1 nanometer problem, which is, I think we're at 5 nanometers now. So, I mean, we have at least, we're going to have a lot more doublings of speed. And I think by the time that when I was describing, when you have 1 GPU per 18-inch panel handling everything, including real-time rendering, at least, like, because if you get to 30, you can basically do interpolation and get to 120 or something like that. Then you're in a pretty good place. I mean, these hologram panels are going to be like the Samsung video wall. You don't buy a single size necessarily. you buy as many as you need, and for the area you want to cover,
Right.
eventually they'll be bidirectional, so they'll record from the panels as well as display. It'll be both. They'll have some sort of haptics for basic touch. You can push and pull on things. Anything else will work. Hand tracking, obviously, even for for AR is a thing. But no, I don't think you need quantum computing for that. I think quantum computing might be really interesting when you're trying to simulate the universe and go a level beyond what we're doing with rendering. And certainly it's possible. I mean, if you think about quantum computers as basically being a way to sort of run a lot of possibilities and get an answer back faster than brute force, then there's options there. I mean, I think that even for things like rendering, but really like almost like impossibly hard renders, it could be there. But I mean, we're just far from even quantum computing being practical in terms of competing with with classical computing. But there's no doubt that there's going to be. I mean, we may just find out that if we wanted to simulate the universe, a Turing complete machine is not quite the way to do it, or what we've thought of as computing for the last 70 years. Quantum computing might be a more interesting way of simulating quantum effects, for example, where the quantum world is not necessarily decidable, and all we know is that maybe the universe, it feels physical, is just a recording of information of a deeper reality. And so if we want to play in that world and play with the possibilities of that, and crack passwords faster,
I was going to say, like, encryption is like out the window if that happens.
You for sure. So encryption is probably going to be the very first thing that quantum computing will probably be practically applied to, because, and frankly, you need now, as many are, you can also use quantum entanglement to essentially at least make sure if you're sending data that no one's listening in. So those kinds of, the problem with that kind of approach is that if on the device there's still a gap where if somebody puts a virus on the device, it's sending the quantum entangled information. You can still find out what it is, just like anything. It's not it's going to be hard to foolproof everything, but it is something where it's dangerous, because if you think about all the things that have been sent ever in encrypted form over the internet, quantum computer in the future might be able to crack all of that. Yeah. So that's a tricky situation.
I've been watching some stuff on that, and some people are discussing that they don't even understand how half of it works. Like in essence, it's almost like it's channeling power from parallel universes in order to work or something. And I'm just like, I don't even understand. I don't get it. But it sure is interesting.
It is. Well, I think the parallel universe approach is interesting because when you look at the quantum world, it is, generally speaking, a probability curve. And the crazy things that can happen with that is if there's a chance that something happens and you don't really observe it, or you don't lock, and observing doesn't mean your eyeballs, it means that it gets recorded, in our information, right? Information is the core of everything. It's like information is the one bit is like a quarter of a black hole's tiniest black hole surface area. There's like a limit to how much information can be processed and stored in the physical universe. It's possible that when our sensors get better, we can see the change in mass on a hard drive when you store more data. That's possibly likely to happen. So where quantum computing fits into quantum theory in general is fascinating, is that indeterminate state of possibilities is something that includes possibly an overlap of all these different elements. And what we sort of see at a macro level, where there's sort of this one thing, it doesn't necessarily apply. But information theory is all about that. The very fact that Claude Shannon, he created the idea of compression, of what a bit is. It's just flipping a coin. I mean, Shannon entropy is probably a deeper reality than energy and mass and all this stuff that we see in the physical world. So from an information perspective, this all makes a ton of sense. And information is interesting because we can imagine almost anything, and that exists somewhere. I mean, like Beethoven's Fifth Symphony exists before Beethoven was alive. He just pulled it out of the ether, so to speak. And the same thing with infinite monkeys typing Shakespeare. Shakespeare existed in theory in a universe where that could happen. So quantum computing is a lot like that. It can sort of pull into these possibilities that could exist and that may exist, and give you back something that's an interesting or meaningful result if we apply it right. But I think the universe itself is like that. I mean, that's why if we're running in a simulation, it's not like a video game. It's much more like an information state system that collapses in ways we don't fully understand. And I think that's why it's so interesting and fascinating. But there's a lot of people throw up their hands with quantum theory in general, because it's like we don't fully understand entanglement in this or that way. We're still figuring it out, and of course we don't understand how the universe works. There's no theory of everything. We're still figuring out what dark energy, dark matter is. So we're not at a point where we even know what it would take to simulate the universe, or what's beyond even that frontier. But again, quantum computing is a fascinating area, and we'll probably start to answer a lot of those questions as people really work hard to make that happen, and to see what we can sort of crack from that, both on the computing side and also philosophically and even on a practical level.
I hope AI helps us figure that out, and if anybody listening has not read up on the double slit experiment, Like it's mind blowing. It's crazy.
You know, the extension to that is when you basically hold the results for a while. Basically, if you open up the envelope in the future, one of the results is trapped in a mirror from the double slit experiment is then changed in the past. So it's one of those things where it's not just for space; it's for time as well. And the idea is that you have essentially, based on how the world is observed, how information is generated in a fixed way that is then shared informationally with everything else that is looking at it. You can start to see a chain of things. I don't know whether infinite universes collapse into one is probably more sophisticated than that. But yeah, the double slit experiment, where depending on how it's observed, you get a wave pattern or you get a single photon or a stream. It goes through time, and that's the craziest part of it, is that you have this thing where you do something in the future, it'll change something in the past, because that entanglement, that probability, unless it's sort of informationally exposed to the air, so to speak, like the Schrodinger cat thing, right? It goes backwards in time too, which is wild. So yeah, reality and time and space as we know it is certainly more squishy and interesting than I think even the theory of relativity sort of implies at face value.
That cat's got to be dead by now, though.
I would assume.
I wanted to also ask you, because we're talking about all this future stuff, about like where you think the metaverse is going.
It's a great question. I think that sort of my chagrin, the metaverse now has been a mainstream word, but I don't think it means a lot of things, because you have fridges with metaverses in there, and I'm like, what? No. So going back to a step where, I mean, even NFTs, I feel weird talking about using that term, because I want to talk about digital art, which is an idea that I had long.
I hate the term NFT. It needs to be rebranded. I've said that a million times. Yeah.
Art. You create a piece of art and you sell it, or people can do things with it. Great. The metaverse is like that too. I mean, the metaverse ultimately is a spatial, reality that you don't have to live in it, but you can actually experience it. I mean, that's VR. It was kind of the very first steps to that. But at a simplest level, like, let's just imagine that instead of a web browser, you have a universe browser, a spatial temporal browser, and everything that you can experience in a 2D screen is sort of spatially there. And whether that's in VR or holographic display or in your mind, it's kind of like, let's imagine the internet just organized in a spatial way that allows you to not just look at images. I mean, even NFTs, right? They're mostly, and maybe you get a GLTF in there, but they're mostly 2D or documents or things like that, just like the web. What needs to happen is 3D needs to become the baseline of everything. And therefore, when you don't have to worry about what a 2D thing is, when you essentially have everything sort of organized spatially and temporally like the physical world, and that becomes a new internet, that's mostly what the metaverse is at a foundational level. You need a lot of computing, you need a lot of things. Now, what is the metaverse used for? You can play games in it, you probably can watch movies in it, you can create shared experiences in it, you can certainly build anything in there that your avatars or that even the physical world can sort of be overlaid in. And that's not that different than having, Google Maps overlay 2D things, or, on Google Earth, or 3D objects even. But it's like that kind of spatial web is where things begin. As far as artists are concerned, as far as the metaverse that I kind of interested in, I think the idea of making content, and this is where virtual production is interesting. If you can start recording things and making artwork, and even have AI tools like Midjourney work in 3D, and everything is 3D, you have one piece of it, which is at least the data, the assets, and everything are now spatial, and they're not limited to a 2D boxed window. So if you want to think about how the movies in the metaverse might work, you may just, and this is what we're doing with the Roddenberry Archive. Like, we started like, well, let's build the real thing. Let's build the enterprise down to the toilets flush, the things are there. The provenance is so deep that like all of the notes, everything there, all the different versions and every timeline's there. So if you want the story of Star Trek told, you can render that to a 4:3 aspect ratio for the original series. And we're doing that, and we have actors. We're building the costumes, scanning them. I mean, it's going to be like a recreation, and then we can also tell stories that, like, from the scripts that weren't ever filmed, and all that's there. So from a metaverse perspective, you have everything that you had in the old medium, which is you can watch something in 2D, but you now have the equivalent of like, I don't know, the internet or Wikipedia. You can go in and you can look at things from different angles. You can experience those things, and that, to me, is already fascinating, because if you wanted to tell stories and even share those assets or those things, it's not just about sharing the 3D models. It's like, how do you combine, like behind me, I have these crossover things, or the painting that Alex Ross did of Star Wars, Star Trek. How would you create that in the metaverse and not just have it be a mashup or Fortnite, where just everyone's just moving around doing things? Like, there's still things where the idea that we have with this M token is that it's starting with people and starting with Gene Roddenberry and starting with Alex, is not just to store their art, but in the case of Alex, in the case of Gene, you know, like there's an actual storyline. There are things there are rules within those universes that make sense. So I think being able to play in that world or experience stories in that world or make your own stories with the permission from others and riff on that is fascinating. That to me is the metaverse in a nutshell. And it also forces you to think about what is the Enterprise? Is it the one version of it? Is it the, you know, in this movie, or is it the ship of Theseus, where, you know, and I think in the actual storyline, it is that. I mean, they take all the pieces of the Enterprise apart from the TV show and they add new ones, and it's the same ship, you know, because it's been replaced piece by piece in the movie, but it's a completely different model and it looks different. But the essence of it, the essence of that is what the metaverse version of the Enterprise is, plus all the stories that are told around that. How that web works is why I want to start, you know, having art connect to that. And I feel that's fundamental. By the way, if you want to have an AI trained on telling Star Trek stories and re-rendering Star Trek stories, you'll have the database for that.
Ooh.
I mean, you know, exactly. Yeah,
I like that
so,
idea.
Yeah,
I want to take an AI and feed them only scripts from The Simpsons from season 1 through 10, but none of the other ones, so that I can get some good classic episodes.
Yeah, and I think that's something that GPT-like things will be able to do really well. But I think that what they're missing, and this is maybe where you combine these things together, is you want to tell a Star Trek story, like somebody wants to make a movie. It could be J.J. Abrams, it could be me, it could be the Ghost of Gene Roddenberry from all the things he's written. Or it could be, you know, on fanfiction.net, there's, you know, 100,000 stories in every milieu. And some of them are beautiful stories. Like, they're really well done. And frankly, a lot of fans submitted scripts and they became Star Trek writers. So my view, and I think the Roddenberry estate shares this as well, is that at some point, and CBS allows this, right? You can make 15 minutes of your own Star Trek thing. Imagine if you gave people the tools to really make that work and give them, like, here's a parallel universe where your story takes place. Just like JJ's, you know, movies take place in, you know, a different Earth, and there's a crossover, and Spock does this and that. But, you know, most of Roddenberry's Star Trek stories, including his novelization of the motion picture, is slightly different than what's in the movie. Like, you know, Kirk has a wife. It's not in the film. It's in Roddenberry's novelization of the movie. Things like that already mean that the story of Star Trek, even from the creator's perspective, you know, there's a universe where Han shot first and Rita shot first, right? I mean, these kinds of things are meta, but they exist. And the idea of sort of, you know, doing like quantum, you know, sort of collapse, with, you know, wave function collapse, is like you look at one version of the story, maybe that's what is canonical from the studio's perspective or the IP holder's perspective. But to be honest, we're living in a world where there's three, I'm not spoiling anything, there's 3 Spider-Man in one movie, and you've got different, you know, movie studios. Yeah, I'm sorry.
That's all right. I know.
But I could be speaking about Into the Spider-Verse, where there is literally every Spider-Man, right? So my point is, you're in a world where there's like, you know, I'm so sorry if I
no, you're fine.
But,
no.
But
it's my fault for not seeing it.
I was gonna say,
I knew.
yeah.
That's funny.
Yeah. So it's but that meta narrative, Matthew Ball, who writes about the metaverse a lot, why I love, and he writes about us too. He's an expert on the metaverse. I think he's clued in on this really early, which is it's the narrative context that we're now in, where it's like you have the Flash movie, where it's like Michael Keaton's coming back, and all these things, everything that ever happened exists. There's an omniverse of these things. That's why NVIDIA calls this stuff omniverse. That's why Fortnite takes place in the omniverse. All of that is the new normal for sci-fi, for genre, for fiction, and it gives us, and just on this face value, it's crazy because everything could be real, but organizing these things in this way and telling stories and making that feel meaningful to humans and fun, I think is one of the things we hope to do, even with these archive projects and working with others. And I feel like that's an important part of metafiction. We'll see. There's room for everything, but that is something that up until I think this moment in time, even on a cinematic scale, like Marvel Cinematic Universe changed movie making. And now we're looking at studios working together to combine properties. I mean, there's an organizational way of approaching that in the metaverse, I think, would be very important. And that's what Wikipedia does for information, right? And it's not perfect, but you can find tons of stuff in a well-organized way. And then you have wikis like Memory Alpha, which are done by Star Trek fans with 50,000 articles. And it's still in the same sort of core database. You can reference ideas and assets textually or through links. But imagine if that were a tool that you could use to create art or tell stories or experience stories or explore even history, right? I mean, they're all these things. Like we're not just doing the Star Trek episodes. The director that filmed The Cage, the first pilot, interviewed part of that stuff, his input. He also directed the Batman Adam West pilot. Like that's his entry in our system, right? You could explore these worlds, both in universe, out of universe. Super important. It's really for authenticity. Did I use AI to do this or that? I mean, the history of how work is created and how IP is generated is very important, even for deepfakes, right? Which is a thing that we want to think about, like having a sort of standard way of approaching how this was recorded, how it was created, and who was involved. I think will really play a big part in solving some of those problems.
And by the way, I guess you mentioned that the Star Trek Motion Picture Director's Edition has something Octane related in. Are they coming out with a new version?
It's out. It came out on First Contact Day, which I think was April 4th. There are, so I'm not yet, because I think it's still playing in theaters, believe it or not, you can actually go see it in theaters. It's limited release. Yes, as it turns out, I found out because the people that worked on it also are working with me on the Roddenberry archive, that there are 3 shots at least that are done in Octane, and I was like, and I didn't know going into the movie because I was invited to the premiere of it. And I knew exactly which shots they were, and they're beautiful shots. The Enterprise, beautiful. I mean, I love that movie, and I love the practical Kubrick-like effects. Douglas Trumbull, who did 2001 and the Star Trek motion picture, and I mean, it fits that world perfectly, and it's a beautiful way of using Octane. There's more to that story, by the way, of how our tool sets were used in that film. That I think probably. I think in a couple of months, once it's out of the theaters, I'll be able to share all the behind the scenes, or even hopefully Paramount will be able to do that. But yeah, it was amazing. That movie is a classic, and it had to look like the practical model. And so one thing I did learn is that the model that was used, because it's not the same as what's in the Roddenberry archive, because we've been rebuilding all these things, like the model that's in the Roddenberry archive is that plus a million times more, because that's an 8-foot model that Jeff Bezos has in his office because he bought it from auction. We have that version in the Roddenberry archive created by the people that also created it for this, but then we have the full 1,000-foot version with everything there. And I'm like, wow, imagine if for very similitude, you're telling another Star Trek story, or even retelling the stories with those pieces there. You're looking at something that feels real. That's why practical effects come in, and CG is always like a shortcut because you don't want to build it physically and whatever. But maybe there's a medium where those things converge. But yeah, the Star Trek movie being done in Octane, and there's also, by the way, studio movies that are done in render on the decentralized nodes on people's machines. I did not expect that. I always thought you'd have to go. That's why we have the Amazon and Azure nodes and Google nodes there, so that you can do your Marvel movies on there. I'm not saying this was a Marvel movie, but it was a it's a movie that is recently was done on average people's machines, because render was faster and cheaper and available, and it was a cost decision, and that's great. That's what the system's there for. But there's so much more that we want to sort of add to that with real time and with all the artist tools for Providence. I'm not going to call it NFTs, but the concept behind NFTs in the metaverse, all those pieces are part of where I think render needs to go. And we have, by the way, just generating AI nerf is a huge render job. So just having that on network is going to change people's lives, because you just don't need to go and wait for that. It's in some ways it's even more intense than than actually rendering things. It's a much more computationally intensive process. Happily, it maps to GPUs really well. So. Yeah.
Well, what do you think about these new series? Now, I have a bone to pick with Picard, but what do you think about Strange New Worlds?
So I am biased in that my best friend Rod Roddenberry, who is the chief of my project, the Roddenberry Archive, is all hit for him. He's a producer on all the shows. Now he has input in these things. Like he was, I think, hopefully it's safe to say that he was the one that insisted that Rebecca Romaine had dark hair, because his mother played number 1 in the pilot and also played Nurse Chapel, who's played by now another actress. So things like that are sort of important. I mean, I would say Strange New Worlds is my favorite out of all the new shows, even more so than Picard.
It is so good.
We worked, by the way, on for the first time outside of our normal stuff. We worked with CBS on one of the shows, not something that's out there yet and is separate from the movie. This is Otoy actually doing some production work, so that'll be out, and I can't wait to talk about that.
Ooh.
But I think that from a story perspective, I'd say Strange New Worlds. I mean, there's a lot of issues that immediately people realized when we put out our stuff. We did the cage; it looks exactly like it did in 1964. We got the same costumes; nothing's different. And Strange New Worlds takes place 5 years after that, but you're already seeing, is this really the same ship? It's like a little bit larger. I mean, people have been recast. There are 2 people playing Savick, right? In between Star Trek 3 and 4, it just happens. But I think that what's more interesting is, are they staying true to the story beats that were there? Even if you consider Star Trek to just be like Shakespeare, it's a written word, right? The story of Star Trek is what matters. The visual renderings of it could be animated like Lower Decks or the animated series, or you can flip to more realistic, and maybe how you interpret the ship, it looks a little bit longer. I mean, these are all things where in our version of the Roddenberry Archive, I mean, there's 17 versions of the Enterprise model, and there's different timelines that Gene wrote or didn't write or there. And so from that perspective, this fits in that context. The question is, are you sure that this is exactly what was shown in the 1960s TV show? But even Roddenberry, and then opening the Star Trek novel, the one he wrote, and he's like, Kirk is prefacing saying, everything you're reading in this book is the only truth, and I don't like how I was portrayed in my adventures, they were exaggerated, implying that maybe the Star Trek TV show wasn't exactly what was happening, but close. So even Roddenberry was like embarrassed by the animated series, the original series, and wanted to have those look better. And ultimately, it was decided, no, those things they happen the way they look. That you see that on Star Trek, The Next Generation. Picard and Scotty go into the original Enterprise, all the way to Archer in the last series. So it's really only with Discovery and later that there's this implication that maybe things don't look the way they used to. But you have a million fans who are like, oh well, this happened because the timeline was changed when Picard went back in First Contact, obviously. So I'm like, okay, maybe that works. So I think that. But in terms of the quality of the show, I do love Strange New Worlds. It's a really great Star Trek. I love Ethan Peck as Spock, and I think Anson Mount's great as Pike. I mean, I feel like they're doing good stuff. So I'm a huge fan. I love it.
The womanizer aspect is so Kirk-like, and like I just feel like they're really grabbing the essence of the original. And I wasn't a big original fan. I'm a Next Generation fan. But like the essence is just there. It is so good.
Yeah.
And same applies. Interestingly enough, I don't know if you watched the Orville, but the essence of Next Generation and the Orville, and like it's like they have moved away from the comedy. Like it's becoming like a
real show.
Yeah, it's really
a real sci-fi show.
Right.
And you're right. Tons of people. So Rod loves the Orville. Roddenberry Mission Log podcast, which covers all the Star Trek shows, it does recaps of all the episodes, interviews, does the Orville, right? Doug Drexler, who works with us on the Reinberg, who's created so much of the visual history of Star Trek the last 30 years, works in the Orville, loves the Orville. I mean, the Orville is like this. It's a cousin of Star Trek, and I think everybody involved in Star Trek loves it for that reason. And Seth MacFarlane's brilliant. I mean, that he loves Star Trek, and I've met him a bunch of times for the stuff we're doing with Otoy. But this was like, I mean, I think he wanted to do Star Trek, and in the end, probably smartly so, just did his thing and created something beautiful that works in its own right. And I think it's
like Galaxy Quest. Galaxy Quest isn't an official Star Trek movie, but it could be.
But Julie and I have been watching Strange New Worlds and Orville simultaneously back and forth, and we're almost starting to confuse some of the plot lines. And it's like, wait, was that on that show or was that on the other show? I can't remember. Which universe is that? So
that's why each universe needs to be documented, so you know what goes where, right? Yeah.
Yeah. Man, that's a lot of stuff.
I'd love to touch on render a bit if
that's
we
what
can.
I was gonna say.
You know,
Any new
because
developments?
there was an announcement on Twitter, on the render Twitter, about RNP001 Burn and Mint Equilibrium. I
don't understand this stuff enough to talk about it.
I am dumb.
Yeah.
And so I need you to dumb it down for me and kind of give me some updates as far as what's going on.
Yeah, no, I mean, I feel like there's big stuff happening, and there is. And what you're discussing is basically a request for proposal. So before we get into what that is, and that is, people are asking, what's the new token economic model for render? Because what I imagined in 2017 was very simple, and it was very much based on, like, we're taking Amazon, we're replacing it with a token, and eventually our artist IP will be entangled in that. We've had, since those 5 years, we've had partners like, MultiClient, that was publicly announced. They basically invested in Render, and they have helped tokens like Helium, for example, which is basically a utility token for Wi-Fi and other things. And they're like, you guys need a better model. Like, there are people that are not for artists, not for no artists, but people in the middle. What if you're, there's so many more opportunities that are there, and I agree. I think that the world of how the blockchain and even tokens work is radically different than it was at the beginning. So we want to have a new model, but the thing is, that's not for the tokens, and that would provide people, for example, liquidity providers, which is what this proposal from MultiClient, by the way, and others can sort of add or change that over the coming weeks. It provides a way for you to actually use Render in this other form. The big change, though, for us is not Otoy running Render and doing this, is that we have to have this thing be a decentralized entity. And we've had subsidiaries that handle Render within Otoy. So the biggest news of all, which is I think lost on a lot of people, is that we are starting a foundation. It's officially, I mean, if it wasn't news before, it is now. That foundation is going to be really at arm's length from everything we're doing. We're going to make sure it's populated by people that know what they're doing, even some people we've worked with. But ultimately, it's designed to have ownership over the Render network, not have us do it. Because we're a U.S. company, and there's only so many things you can do in that space. And that's why decentralization is so powerful and interesting. So with that foundation, which I think we're looking at setting that up for July. Again, I'm sort of saying in the Telegram, like, you have to be careful with dates. There's a million different things, and a lot of it is just from a governance perspective, even just from how you operate legally. Like, you just can't do the things that people are sort of asking of the network from an entity or corporation running these things. So the other thing about the foundation is it really does come closer to a community system where you'll have the equivalent of DAOs where people can vote on things. So starting with the economic model, I think multi-coin's proposal is really good. And I think there's other people that immediately like, I think this could be better, and I'm going to propose something. So there's already a system in place now where those things to be voted on. So it's not that we're going with the multi-coin model. It's just that that's one of the approaches. It's certainly well thought out. I think it's pretty good. And ultimately, the process with the foundation getting up and then voting on these things will allow us to then, pick this model and start implementing it. But not us, Otoy, or me, Jules, but the foundation, which, while we may have a lot of influence, and Otoy will probably work with the foundation on a lot of things to provide the things it's providing. That's the future where, there's an open system, and there also is where things are a lot more transparent. There's like a lot of the, the concerns around what are you doing with this and that of the system. Like this is something that can be fulfilled in terms of describing all these things, even retroactively by a foundation. So those are huge things. That's why it took 6 months to even figure out all those pieces and get all these things ready. And we're now there. So I think this summer will be really exciting for Render, and I think in tandem to that, we have many other important pieces that are sort of coming together, including all the stuff I was describing with, the NFT/metaverse pieces, the stuff we're doing with Solana, which is fundamental to that. I think we'll have some pretty cool surprises in terms of how those will work that people might not see coming. Although I think I've described maybe 80% of some of those pieces on this call. But there's still more. And I also think that there's a lot of volatility in the crypto space. There just is. Like, there's no we try Render from the artist and node operator perspective, although we haven't done everything perfectly on those fronts. It's meant to sort of smooth that out. And I think that for the rest of that to work in a way where everybody else in the crypto space kind of wants to apply those same principles to Render, the foundation is the way to go. And I'm also just happy that we have partners that can advise us on this. I mean, that's where the 6 months kind of has been. How do we do this right? How do we get the right advice? I mean, it's really, we're dealing with things where it's just not well understood or well known or even well, laid out in across different jurisdictions or states, and so it has to be done carefully and thoughtfully in a sense that I want the system to grow and I want it to be a fundamental part of the metaverse, like computing in the metaverse, art in the metaverse. These are things that Render should be able to do, and it shouldn't be one company or me or whatever deciding these things. I mean, that's where the power of an Ethereum, for example, and other properly managed chains and projects. I mean, there's a lot of value to that. And I think that we need to get to something like the open web. Mozilla is still my inspiration. Brent and I going and creating JavaScript and then Mozilla and then basic attention token, and even thinking about the browser as an important fundamental piece, even in 3D for the metaverse and all these elements. We need something to go there. And I've been trying for years, even within Otoy, to do things like ITMF and open standards and contributed things. So Render is ultimately maybe the bigger fulfillment of all these things. Like, there will be sort of this organizational entity that we contribute as much as we've always been doing to Render, but also have it be essentially something that the community and the larger ecosystem can have ownership and vote on to all these things. And I think that's one of the reasons why I think we went down this path, is that that the whole blockchain space and the decentralization aspect of it is incredibly powerful, and we're seeing that. The fact that Render exists even to this point where we have probably 1 million GPUs on the wait list. At some point, even I think the guys at Midjourney are going to run out of GPUs on whatever project they have, right? And here we got 1 million. So as things scale, as AI, and no matter what you're doing, compute is going to be fundamentally important. And I think we've got a really good system for that, and a great set of tools and partnerships around artists that want to leverage that.
I see the future of Render. And I'm on the Render subreddit and stuff like that. And anytime someone asks something, I feel like because we've spoken so much, I have a really good understanding of the future of where Render is going. And I think people will only kind of see it as, oh, well, you render frames, you get paid back. But it's like, there's so much more to that, having a decentralized GPU. And, I don't know if y'all have currently or are in the process of building an SDK for people to be able to use externally, not just for rendering frames, but for doing AI work and doing all sorts of things, and with that, the Render network's going to have to grow exponentially, which means there's going to need to be more node operators. There's going to be, more of everything.
Yeah, I agree, and it's true. You're right. It's not just rendering in and out. I mean, there's a lot of, I mean, the AI stuff alone, and I'm glad that we're to the point where this very conversation we're all having is post Midjourney, right, coming out, and because there's I'm assuming most of our Octane users also are aware of Midjourney, and that's great. So you can start to see that even the and it costs money, right, to use. I mean, there's, I think they say $4 per GPU hour. My point is that the scale of how art is going to be created, even if AI is at the middle of it, is not a solved problem. But there's so much more beyond that as well. And I think that the concept of having something that allows you to organize things. I mean, if we didn't have the web, you would never have gotten to the Amazons, the Googles, even Apple putting Safari right into the iPhone was why the iPhone was the iPhone. Not to mention social networks like Facebook and Twitter. I mean, the web created those things. And there may be this sort of aggressive sort of retraction into apps and verticals and isolations, and this didn't need to happen. You could have had Mozilla work on the Firefox Phone OS, which gives you permissions to all these things, and there could have been WebGPU, for example, which is still kind of a thing that gives you almost everything CUDA or Vulkan could have. I want to see that happen. So for us, these things start from one company sometimes putting something out there and making it a standard or spec, and others contributing or changing it or adopting it. And we have to do that. And we have SDKs as well for developing on render, but there's also the possibility of other people creating SDKs that can tie into that. And that work is fundamentally important. Working with partners early on that are already doing this stuff, like the Midjourney guys are great. I mean, obviously we're working with other 3D tools, other renders, doing actual things ourselves, pushing the envelope, even if it's small form content like what we're doing with Roddenberry. It's like there's so much there, and the fact that honestly, even the NFTs are a crazy space. I mean, there's probably hundreds of millions of dollars that are done by Octane artists. I mean, obviously, Mike's a big part of that, but maybe $1 billion or something at this point that's not nothing. Now, granted, and I do feel that if you're creating something in Octane as an NFT, I mean, if you're selling your art, that's fine. Like, I think a lot of the NFTs that are just spitting out an image and it's speculative and all that is not great. But I do think that there is an absolute, I mean, I talked about this photon-driven economy in 2017. This is before NFTs were even a thing. And I said, there is a way for creative individuals to make money on this system, node operators to make money fulfilling that. And that system is yet to be created. But I think that's the closest thing you'll come to seeing, the metaverse in an ideal way, at least being, fully realized. And I love that the artist's workflow is becoming easier and more democratized. I mean, that doesn't mean that there's any less creativity going into it, but the point of Octane was to make rendering easy and to make it easy to use for C40 users, right, that didn't have that kind of thing before. And we're still on that path. And all of those things, especially as we look at, we're putting out an iPad app, an iPhone app. I mean, I think a lot of those users aren't going to be coming from the C40 or Mograph world. They might be much more new to content creation, but still having that kind of power and letting them be creative, I think is fundamentally going to be a huge part of all of this. And we don't know where that's going, but I think in the next few years, you'll see these things all really start to stitch together really nicely.
Now, we get a lot of questions that are kind of over our heads, and because it's not related to art or animation or Octane specifically, it has to do with render and tokens and things. And so, like, is there a place people can ask questions? Because, like, you see here in the chat, someone's asking about the payment system and things. Where's a good place for people to go? You have such a great system for, like, feature requests in Octane, right? Is there something like that for render too?
Yeah, I mean, part of the thing of doing the foundation is there'll be a dedicated organization that has its own really dedicated support infrastructure for those kinds of things. But as far as the node operators go, like, for example, there's a node operator Slack. I'm sometimes in there, and yes, I mean, I've seen what there's a payment system. So
am I. Yeah.
Yeah. So I mean, there's a couple issues. One of the things is having both layer 1 and layer 2, which was layer 2. Those aren't familiar. It's Polygon. It's Matic. It's faster. I mean, but resolving those things, having both at the same time, has caused a bunch of backlog problems. We're probably going to have to settle on one for the most part. We're looking into that. And then the other thing is that there is an issue that has come up where people don't finish jobs, or they don't have enough of render in their wallet to finish the job, and then it gets stuck in a loop. And that's actually another area of backlog that I only really got to the bottom of in the last month or so. So we're going to fix those things. That's where, to the question that's asked here in the chat, that's where we're at there. And I want to do that immediately. The team is on there. I do think that we'll have a lot more alacrity and even dedicated channels for specific support for node operators with the foundation. I mean, that's where a lot of that can go. As far as artists, I mean, that's a different world. I mean, to me, the artist feature requests for render are the same as the feature requests for Octane or Brigade or anything else. Like, we kind of all know what we want to be able to do. I mean, it's not like it's a mystery that you want to be able to have, no export to Orbex and simplify these things, right? Send your CPU. I mean, these are all things that make sense. We're still developing a lot of that. So I think once those things are done, then having more interesting things you could do on chain, for at least from our side of things, or at least in the SDK or API, that will work. There's also, of course, in the same Slack, right? There is the artist, channel as well, and maybe there's a separation that should happen for that, because not everything is going to be Octane, right? In the future, so that's where the foundation can handle dedicated things related to other renders. Otoy will still help with that, because I think we're still going to be for years to come building fundamental pieces of render, but we're going to be doing it for the foundation, and that will at least allow there to be sort of a dual focus. I think as far as a lot of the other questions of when you move to Solana and what's the new, these things will be sorted out in the coming months, but already you're seeing the big pieces fall into place with the proposal for the token economics, which is how this would have to happen. Like, we don't want to just by fiat say this is it. We needed the process and the foundation and this thing to let, even if we kind of have an idea of where we think this is going to go, and certainly our partners at Multicoin do. Already I've seen that having people that are really smart to know this space. Burnham, all these things, it's a dark science, right? It's hard to get these systems right. So if you're going to go into anything like that, having experts all over the industry have a month or so to review these things. In fact, even when we implement it, it could still be voted on and altered a little bit later. Like, that's fundamentally important. And I think that we're going to do the same thing for how nodes and other things are operated. But at least, there's a pretty strong roadmap for all these things years into the future that I know I want to see. And it's a question of, are we as a community feeling the same, is everything going smoothly or not? And if it's not, then at least having this sort of officially, centered foundational piece where these things go, where we will be on the hook, of course, as Otoy for things that we're connecting. The foundation and Otoy will still be working on these things. But that's where I see an improvement coming there. I think that for now, the Slack channel for node operators and artists is not a bad place to go. Telegram is a bit messy. There's also the Discord. We have a new Discord.
There's a new Discord too. Yeah, I noticed that.
And Discord has got some fascinating, unique features. It's not my favorite thing in the world. I'm generally on the Facebook group, like, I answer everything. And sometimes on Twitter when I can. And there's some Twitter posts where, like, I'd love to answer the question. I can't. Like, just wait until there's a foundation done and this will all be sorted out. But I do think that we're probably going to have the Slack continue to grow, and maybe we'll see how the Discord channel does. But that's kind of where certainly for render specific things going forward, there'll probably be a lot of members there that can help. But we're also dealing with what happens when you have third party things that are nothing to do with any of these pieces, right, that are running on there. So we will probably be having the foundation set those pieces up and helping have channels or forums dedicated to these things. And we're kind of like, I think we're in a decent place with Slack. We'll see how the Discord stuff goes, and if there's a better version of either of those things, or even a dedicated website, which will definitely happen, we'll look into all those things. But right now, I'd say the Slack is a pretty good starting place for technical questions and support.
And there's not a lack of places to get a hold of you too. I think over the years, you've
I'm
proven
everywhere.
that.
Yeah. If you Instagram me, I'm barely on Instagram, so that's I barely am there. So, but the other things I check much more frequently, including the Telegram and Twitter and the Facebook group and everything. I try to be everywhere I can, the forums as well. So, but we also have a growing team. We've actually expanded the team a lot on render just in the last few months, and more to come, a lot more. So I think that there's going to be a lot more people that can help with all this.
Yeah, and I do have to say, more. You've really shown that over the years that you're listening to what artists and people are saying, for sure. You can see that.
I do have to say, with the addition of the new Orbex exporter in C4D, it's excellent. Like, I like being able to see my process and see how it's going, and I love the idea of being able to set it as an additional thing that gets exported when you render. Like, so say I'm rendering locally and I'm just rendering it like 512 samples or something, and if the client approves that, I can upload that to render, that Orbex file to render, and set it to go, which is fantastic. I really like that. I do still run into some issues, but I will say, considering they have gotten considerably better over the past year from working on our big projects and having to do that. Then there's a few things I got to send to Amit. He's like, hey, can you help me? I'm like, sorry, I can't. It's all NDA. Right. So I got to create some stuff myself. Yeah.
Yep. No, the Orbex exporter is going to always be there. It has to be, because we have no idea whether you know, I mean, especially when we're depending on a third-party library. I mean, like Cinema 4D or even Unreal, it's important that we maybe store and support the C4D hub, but having something on render that also can spit out the Urbex, or having that option always there for preservation. Even everything we do in the archive, we'll have all these things. We'll have the Blender files, but there's always an Urbex, because we can't know for sure, even for Blender, right? I mean, it's open source. You hope that the versions change. Like, at least the Urbex is something like, we have Urbexes from 12 years ago that rendered just fine from Octane 1 in Octane 2022, not whatever. I mean, you know, and it's amazing. So that's important, because to be honest, you need that consistency as a baseline. So even if we support other formats or other things or other renderers, we're going to make sure that at the very least there's always this distillation path to rendering and storing things in Urbex, even if you don't need to have that explicitly supported. Because again, I mean, the Urbex exporter should work. It may be a pain in the butt, but it always needs to be there. And in some cases, there may not be other choices. I mean, it's not just this, C4D or Houdini Engine. There's other things.
Right.
And Urbex can still wrap multiple things together. It could wrap, for example, a C4D file and a proxy or cache for it. So it all kind of connects together. And Urbex exporting from Unreal is going to be interesting too, when you have the interactive pieces supported, and you can bring that in and have physics and other stuff in there. So that's also on the horizon, along with a full 2D and video compositor system that'll at least give you a mini equivalent of After Effects or Photoshop right within the IPR window, which I think will be helpful in certain cases.
Absolutely, absolutely.
Well, that's a lot to take in.
Yeah, that is a lot.
I think we'll probably end it there. I'm sure at this point everybody's going to rewind, start it over again, and try and take it in a second time. I know I will be, for sure. We really appreciate you taking the time. I know you got a lot going on and a lot to work on. You got a metaverse to create, and
help create, help foster.
Yeah. And so, we already know where people can get a hold of you. You got, all the things. So definitely anyone, if you have a question, reach out. And we're going to get out of here. You can rate us on iTunes. You can leave a review. You can subscribe on your podcatcher of choice. Help get our ratings up. You can say you've been there, done that. Got the T-shirt with the Mograph logo tee, the Feel the Bab 2020 shirt. All the profits from that go to Doctors Without Borders. You've got the Render Things t-shirt, hoodie, and long sleeve tee, the Mograph Blandishment shirt, and then, of course, the That Render is Fire shirt, which you are only allowed to wear, ironically, unless you're Shams.
Unless you're Shams.
Yeah. And we're on YouTube, mograph.com. Don't forget, if you want to send us an email, info@mograph.com. And you can check out the show schedule at mograph.com/live. I think that's it.
Amazing. Thank you guys so much. This was amazing.
Yeah, thank you, Jules.
Yeah.
My pleasure.
Until next time, I'm Dave.
And I'm Matt.
I'm Jules.
Have a good one.
Thank you.
Later, yo.
Thanks, everyone. Bye.
All right, stand by one moment. I'm going to close this out here.
Should I stop?